Hello, and welcome to your journey into the world of 3D. My name is Evelyn, and throughout this series, I'll guide you step by step through the foundations of 3D graphics using Blender. Whether you're completely new to 3D or transitioning from another software, this series is built for you. We'll move through every stage of the 3D pipeline in a clear, structured way. Simple, organized, practical. You'll follow an industry-style workflow focused on high-quality results and efficient performance. You'll run into real production challenges and learn how to solve them the way working artists do, all while building one of the most deceptively complex objects in 3D, the glazed donut. So, if you've ever looked at a game environment or a cinematic shot from a film and thought, wait, how was that even made? Then you're exactly where you need to be. Well, let's start with the basics. When people hear the term 3D modeling, it can sound technical. But a helpful way to think about it, especially at the beginning, is digital sculpting. Instead of clay in your hands and tools on a table, you're shaping form using points, lines, and surfaces inside a digital space. Vertices, edges, faces are the core building blocks of every 3D object. At its core, 3D modeling is the process of creating objects inside a three-dimensional space with depth, width, and height, just like the world around you. And the good news is, you don't need a background in drawing or geometry to begin. What happens over time, and this surprises many people, is that your mind slowly adapts. You begin to sense depth where there was once only a flat screen. So, if that's 3D modeling, what exactly is a 3D model? A 3D model is simply a digital object that exists in space. You can rotate it, move it, view it from any angle. It behaves almost like a real object on your desk, except here you can reshape it and rebuild it endlessly. And when you create one, you're not just forming a shape. You're creating something that can be textured, animated, and rendered into a finished image. Creating a 3D asset typically follows a structured pipeline. Every great 3D project begins with modeling, shaping basic geometry into a recognizable form. Next is UV, unwrapping, preparing the surface so 2D textures can map correctly onto a 3D object. Then, texturing and materials, where color, surface variation, and realism begin to develop. After that comes lighting, designing how light interacts with the object to define form, mood, and material response. Then, animation, introducing motion and guiding the viewer's attention. And finally, rendering and compositing, where everything is processed into a final cinematic frame. In this series, we'll walk through that entire workflow, clearly and intentionally. At its heart, 3D creation is a bridge between imagination and reality. An idea in your mind becomes something you can see, refine, and share. Whether you're interested in games, visualization, design, or storytelling, everything begins with these fundamentals. Now, let's talk about Blender. Blender is a professional all-in-one 3D creation suite, and when people say all-in-one, they truly mean it. Within a single application, you can move through the entire creative process, from modeling and sculpting, to animation, to rendering, and even video editing, all without leaving the software. Instead of jumping between multiple programs, Blender lets you build your project step by step in one place. And one of the most impressive things about Blender, it's completely free. No subscriptions, no locked features, just download it, install it, and start creating. That accessibility is a major reason Blender has grown into one of the most widely used 3D tools in the world. Blender also has an interesting history. It began in 1994, created by Dutch artist Ton Roosendaal as an internal tool. Over time, especially after becoming open source, artists and developers around the world contributed to it. Version by version, It evolved into one of the most respected 3D tools today. So when you learn Blender, you're learning a living tool, constantly improving and growing with its community. Having said a little about 3D graphics, now let's move into Blender setup. First things first, we need to install Blender. If you're on Windows, visit blender.org and download the recommended version. Run the installer, follow the steps, and complete the setup. Then, launch Blender from your Start menu. If you're on Mac OS, download the disk image, open it, and drag Blender into your Applications folder. Then, launch it like any other app. When Blender opens, you'll see the splash screen, your starting point. Click anywhere outside it or press Escape to continue. Before we move forward, let's break down the interface. At the top is the top bar. This contains essential menus and global controls. In the center is your workspace. This is where you create and interact with objects. At the bottom is the status bar. It provides shortcut hints and system feedback. On the right side, you'll see the outliner and the properties editor. These panels manage scene structure and object settings. Blender organizes tasks into dedicated workspaces. There's the Layout workspace, which is great for general scene management, Modeling, where you focus on shaping geometry, Sculpting, which is more like working with digital clay, UV Editing, where textures are prepared and aligned, Animation, with timelines and keyframes, Shading, where you create and edit materials, Rendering, where you preview and finalize your output. Geometry Nodes is for procedural modeling, where you manipulate geometry using a node-based workflow. And Compositing Workspace is for post-processing your rendered images or animations. You can switch between workspaces using the tabs at the top, or press Ctrl plus Page Up and Page Down. Navigation is another essential skill. To orbit around the scene, hold the middle mouse button and drag. As you move the mouse, your viewpoint slowly circling the object, like you're stepping around it and looking at it from different sides. If you don't have a middle mouse button, you can left-click on this navigation gizmo here and drag it instead. It does the same thing. To zoom in and out, scroll the mouse wheel. And if scrolling isn't an option, you can also click the magnifying glass icon and drag. To pan sideways, hold Shift and the middle mouse button while dragging. This slides your view horizontally or vertically without rotating. And again, if you don't have that button, you can click the hand icon and drag instead. To quickly adjust your view to an object, press the tilde key and choose the desired view from the radial menu. You can also frame the selected object in view from the View tab using Frame Selected. In the default scene, you'll notice several core elements. A cube at the center, your starting mesh. There's a light source, which controls how the scene is illuminated. A camera, which defines what Blender will actually render. A 3D cursor, which acts like a placement marker for new objects. And a grid floor, representing the world's coordinate system, your reference for scale and direction. Before moving forward, it's helpful to adjust Blender for comfort. Press Ctrl, or go to Edit and then Preferences. If you're using a laptop without a numpad, enable Emulate Numpad. If you don't have a middle mouse button, enable Emulate 3-button mouse. In this same window, you can also adjust themes, interface scale, and even customize shortcuts. Once you adjust settings in the way that suits for your workflow, click Save Preferences so your setup stays exactly the way you want it. And as we wrap up this introduction, remember, start simple, practice consistently, improve gradually, be patient with yourself. Every professional artist once started exactly here, curious, uncertain, and willing to learn. In the next session, we'll begin object manipulation and basic modeling as we build your first glazed donut. I'll see you in the next part. Welcome to our donut modeling tutorial. I'll guide you step by step as we build a classic 3D glazed donut, and by the end, it'll look good enough to eat. Alright, let's start from a brand new scene. First things first, delete the default cube. Select it, press delete, and just like that, it's gone. Every Blender project starts this way. At this point, deleting the cube is basically a rite of passage. Now let's add our base shape. Press Shift-A, go to Mesh, and choose Torus. And honestly, this is already doing most of the work for us. A torus carries the core structure of a donut. Once it appears, scroll your mouse wheel to zoom in and take a closer look. You should see something that already reads as a donut. It's not finished yet, but the foundation is solid. Right after adding the torus, look down to the lower left corner of your screen. You'll see the operator panel. This is where we can adjust the object's parameters while the mesh is still live. Here, we can control the overall size, the thickness, and the resolution. Just keep in mind, these options are only available immediately after adding the object. If you click away or deselect it, the panel disappears. If that happens, press F9 to bring it back. Now let's shape this into something like a proper donut. Set the major radius to 1. This controls the overall scale. Then, set the minor radius to 0.4. This defines the thickness of the ring. You should immediately see the form becoming more convincing. Now, quick workflow note. This is something a lot of beginners miss. Increasing the major and minor segments increases resolution. More segments mean smoother curves, but they also mean more geometry. And more geometry means more processing power, which can slow things down and make the model harder to manage. So instead of pushing the values too high, let's be intentional. Set the major segments to 48. That gives us a clean, circular shape. Then set the minor segments to 16. That's enough detail to hold the shape without making the mesh unnecessarily dense. This gives you a really nice balance, smooth and professional, but still lightweight and easy to work with. We don't need extreme resolution here anyway, because later we'll rely on modifiers to handle smoothing in a much smarter way. Once you're happy with the proportions, click anywhere outside the panel to confirm. And just like that, you've built the foundation of your donut. Alright, now let's refine the surface. If you look closely, the shading still feels a little faceted. Not incorrect, just not polished yet. With the torus selected, right-click and choose Shade Smooth. This doesn't change the geometry. It only adjusts how light transitions across the surface. But visually, it makes a huge difference. Instantly, the donut feels softer, like baked dough instead of carved stone. Now, while Shade Smooth improves the appearance, it doesn't actually add geometry. To enhance the real surface quality, we'll use a modifier. Head over to the Properties panel on the right. Open the Modifiers tab. Click Add Modifier. Under the Generate section, choose Subdivision Surface. This modifier increases the polygon count while smoothing the overall form. It's one of the most important tools in hard surface and organic modeling. It lets you work low poly while presenting a high-quality result. In the subdivision settings, set the viewport level to 1, or 2 if your system handles it comfortably. This keeps your workflow responsive. Then set the render level to 2 so we get a cleaner result in the final image. The viewport shows a simplified version, so it stays easy to edit. If you temporarily reduce the viewport level to 0, you'll see the original base mesh underneath. Then increase it again, and watch how Blender redistributes geometry evenly across the surface. This is a professional workflow habit. Keep your mesh light while modeling, and let modifiers handle the refinement. It keeps you fast, and it keeps your scene efficient. Alright? Now we have a clean, smooth donut base, ready for the next step. But, let's be honest, right now it looks too perfect. Real donuts aren't perfect. They settle under gravity, they expand unevenly, they have subtle irregularities that make them real. So now, we're going to introduce some natural variation. At the moment, we're in object mode. You can see that in the top left corner. Click the drop-down, or simply press Tab to switch into edit mode. Now you're seeing the actual structure. vertices, edges, and faces, the building blocks of the form. Turn on proportional editing by pressing O, or by clicking the small circle icon in the top toolbar. This tool allows you to move a single vertex while smoothly influencing the surrounding geometry. It's essential for organic modeling. And yes, a donut absolutely counts as organic. Select a vertex, press G to move it slightly. You'll notice a circular fall-off area appear around it. That circle represents the influence radius. Scroll your mouse wheel to adjust the size. You can also use page up and page down. If you're on a Mac and those keys aren't available, you can remap them later in the key map settings. But the concept is simple. A larger circle creates broader, softer adjustments. A smaller circle gives you tighter, more localized control. Now start gently pushing and pulling points, some outward, some inward, very subtle movements, as if you're shaping soft dough and letting it relax into something less manufactured. There's no rush here. These micro adjustments may seem insignificant on their own, but together, they're what shift the donut from digital to believable. Watch how the surface responds, how the silhouette starts to break away from that mechanical smoothness. As you move around the donut, keep adjusting the influence radius based on the kind of variation you want. Sometimes smaller for controlled detail, sometimes wider for broader shape shifts. Here, I'll push this area down slightly. Move around the model. Select a vertex, press G, then Z, just enough to introduce a soft unevenness. Maybe this vertex comes up a bit, just enough to break symmetry. Let's rotate to a side view. Take a central point, press G, then Z, and slowly lift it. Watch the curve adjust. Maybe this one goes down. And this one too, slightly lower. Then bring this one up very subtly. All right, let's check the bottom. Select a point, press G, then Z, and pull it down slightly, just enough to suggest the dough compressed under its own weight. Rotate around the model. Keep evaluating the surface. I will lift this area slightly. Now let's refine the inner ring. Right now it's too perfectly circular. In reality, that inner edge would never be mathematically precise. Select a vertex and pull it outward. Actually, inward feels better here. Yes, that breaks the symmetry more naturally. And this section, just a subtle inward adjustment. Don't overdo it. This isn't a technical checklist. It's observation. It's sensitivity to form. You're simply breaking the perfection, removing the artificial symmetry. Think about a real donut, slightly uneven, a bit compressed, organic. Try to recreate that impression as convincingly as possible. That's looking good. You can already see the difference. The form feels more relaxed, more believable. We've introduced variation from the top, the sides, the bottom, and along the inner ring. And now it has enough irregularity without becoming messy. That balance between control and imperfection, that's what gives the model character. To push the realism a little further, let's gently flatten the donut through the middle. Real donuts aren't perfectly round all the way around. They compress slightly as they rest and cook. Start by selecting a single vertex, then hold Alt and left-click on an inner edge loop to select the entire ring. Before we continue, turn off proportional editing. For this adjustment, we want clean, controlled scaling. Press S to scale and slowly bring the ring inward just a bit. You can hold Shift while scaling for finer control. We're not crushing the donut, just softening that perfectly circular profile. Even this subtle adjustment makes the form feel less synthetic and more physically believable. Now, here's a small real-world detail. When donuts are fried, they often develop a slight ridge near the top and bottom. This happens because the dough expands unevenly as it floats in hot oil. Let's recreate that. Press Ctrl-R to add a loop cut near the top edge. Hover until you see the preview line, click to confirm, then scale that loop outward slightly. Repeat the process near the bottom edge. Press Ctrl+R again, position the loop cut, confirm it, and scale it outward just a touch. To refine this further, press Z and switch to wireframe view. This makes it easier to see exactly what you're selecting. Make sure proportional editing is still off. Select the lower half of the donut, then press S and scale it slightly wider than the top. This creates a heavier base, a subtle indication of gravity. Next, select the top half. Slowly scale it inward just a little. Now the donut has a soft dome shape instead of a mechanically even ring. Take a step back and evaluate the form. The donut base is finished. It's no longer mathematically perfect, and that's exactly why it looks real. Now it's time to build the glaze. Instead of creating a new mesh from scratch, we will duplicate the donut. The reason is simple. The glaze follows the same overall form. Go back to Object Mode. Select the donut, press Shift-D to duplicate, then right-click or press Escape to leave it in the exact same position. Visually, nothing changes, and that's expected. Now let's organize the scene. In the outliner, rename the original object Donut. Rename the duplicate Glaze. It may seem minor, but naming objects early prevents confusion later. In small scenes, you can sometimes get away without naming, but in professional workflows, especially larger projects, organization matters. Good habits scale. Now select the glaze object and enter Edit mode. Since glaze only sits on top of the donut, we don't need the lower half of this mesh. Press Z and switch to wireframe view again. Wireframe allows you to see through the geometry, which makes selection more precise. Switch to a side view using the gizmo. Click the X-axis so you're looking directly at the donut from the side. Now, select all the bottom vertices, everything below the midpoint. Once selected, press X or Delete and choose Vertices. Press Z to return to solid view, then go back to object mode. You'll likely notice some flickering where the glaze overlaps the donut. That shimmering effect is called Z-fighting. It happens when two surfaces occupy the same space without thickness separating them. So let's fix that. With the glaze selected, go to the Modifiers tab and add a Solidify modifier. Set the offset to 1 so the thickness expands outward. If it moves inward instead, just set it to -1. Now slowly increase the thickness value. Watch the edge carefully as you adjust it. You want it to feel like real icing, soft, slightly heavy, resting on top of the dough, not paint, and definitely not armor. Once the glaze clearly sits above the donut with believable thickness, you're in the right range. Alright, now we have icing on the donut, but if you look closely at the edge, it still feels stiff. Real glaze doesn't stop with a clean, sharp line. It softens, it melts, it slowly drips downward under gravity. So let's build those drips. With the glaze selected, enter Edit mode. In the modifier stack, find the Solidify modifier. Enable the small display icon next to it so you can see the thickness clearly while editing. This just makes the process more comfortable. If you grab a vertex now and pull it downward, you'll notice it can intersect the donut. To prevent that, turn on snapping from the top toolbar. Set the snap type to face and enable Project Individual Elements. Now, as you move vertices, the glaze will stay in contact with the donut surface instead of floating or cutting through it. If you try stretching the edge right now and it looks sharp or faceted, that's a sign the mesh doesn't have enough geometry. So before shaping the drips, we need more resolution. Switch back to Object mode. In the modifier stack, locate the Subdivision Surface modifier. Open the drop-down and choose Apply. This permanently adds geometry to the mesh, giving us enough density for smooth, flowing drips. Once applied, go back into Edit mode. You'll see there are now many more faces available. That's exactly what we need for soft deformation. Now, one important thing to watch. If proportional editing is on and the influence radius is too large, when you pull one vertex down, the opposite side of the glaze may move too. That's not realistic. Glaze doesn't pull through solid dough. To control this, we'll temporarily isolate the area we're editing. Switch to top view using the gizmo. Zoom toward the glaze edge. Hold Alt and left-click to select the bottom edge loop. To expand the selection upward, hold Shift-Alt and click the next loop. Continue upward until the lower section is selected, then press H to hide it. Now only the visible section remains active, so your edits stay controlled. Make sure proportional editing is enabled. Select a vertex along the bottom edge, press G, and gently pull it downward. As you do this, think about gravity. Some drips stretch longer, others barely move. Adjust the influence radius with your mouse wheel as you work. Move slowly around the donut. Select a vertex. Pull it down. Then move to another. Don't drag randomly. Instead, visualize where glaze would naturally gather, where it would hesitate, and where it would finally fall. Some sections should hang noticeably lower. Others should just soften along the rim. Work your way around the donut, building an uneven dripping pattern. Take your time. Irregularity is what makes this believable. Each drip should feel like it formed under its own weight. For example, I will take this vertex, press G, then Z, and intentionally pull it downward. That creates a wider, heavier drip. Now this one, with a slightly larger influence radius, let it fall a bit more. You can feel the difference in thickness. Next, use a smaller radius for a tighter, thinner drip. Vary the size, vary the length. Some drips should be wide and stretch lower. Others should stay shorter, almost held in place by surface tension. Just like real glaze, some drips merge slightly with their neighbors. Others remain separate. Keep moving around the donut, slowly shaping the edge. Here, I might also push a few points upwards slightly. That introduces a soft wave along the rim. Avoid straight horizontal edges. Avoid anything that looks patterned. Lift some vertices subtly. Let the edge feel fluid, as if the glaze is stretching gently across the surface. Some drips cling close to the top, barely affected by gravity. Others stretch past the edge and pull downward more dramatically. Step by step, let the glaze start to feel alive, organic, weighted, naturally formed. Once the shorter drips is done, we can introduce a few longer, more dramatic ones. Start by selecting a single vertex along the edge, then shift-select the neighboring vertices beside it. Press E to extrude them downward. At first, it may look a little rough, almost blocky. That's normal. To smooth it out, add another subdivision surface modifier. If the edge still feels slightly sharp, increase the viewport level in the subdivision modifier to 2. That extra subdivision gives the glaze a creamier, more melted appearance. Now, there's one more detail to refine. If you look closely at the edge, some areas may appear to float slightly above the donut surface. To fix that, select the glaze object, go to the Solidify modifier, and under Edge Data, increase Crease Inner to 1. This tightens the inner edge, so the glaze hugs the donut more convincingly instead of hovering. Now let's shape the longer drip trails. Select a group of neighboring vertices. Take a moment, make sure they flow together naturally. Press E to extrude and pull them downward slowly. Place them where gravity would realistically stop the drip. Then scale the new edge slightly to keep it rounded and soft. Repeat the process in another area. I'm going to carefully select these neighboring vertices. I will extrude them downward, slowly, and then guide them into place, right where I want this drip trail to end. I scale it down slightly to keep the tip of the drip rounded. Rotate around the model, adding variation where it feels right. I will select a new group of vertices nearby. then extrude downward. I will scale it down just a little. That small adjustment keeps everything smooth and organic. Select a group of neighboring vertices. Press E to extrude and pull them downward slowly. Extrude in stages, adjusting as you go. You can scale with or without proportional editing, depending on the shape you're aiming for. Adjust the influence radius with your mouse wheel as you work. Move slowly around the donut. For longer drips, there's something important to keep in mind. If you extrude too far in a single movement, the geometry can stretch and become too thin at the bottom. Instead, extrude in stages. 2, sometimes 3 smaller extrusions. Pause briefly between each step, adjusting as you go. You can scale with or without proportional editing. Introduce subtle variation. Let gravity guide the form. Some drips should extend farther down. Some should be medium length. Others should remain subtle. For longer drips, use 3-step extrusion. For medium drips, 2 steps. For small accents, a single extrusion is enough. This layered variation prevents repetition and keeps the glaze feeling organic. Select adjacent vertices. Press E, then Z, and extrude downward. Scale slightly to keep the edge rounded. Turn on proportional editing by pressing O. I will scale it down just a little. Keep evaluating the surface. Select adjacent vertices and extrude downward. Place intentionally. Scale slightly to keep the edge rounded. Select a group of neighboring vertices and extrude downward. Scale slightly to keep the edge rounded. Select adjacent vertices. Press E, then Z, and extrude downward. Extrude 3 smaller extrusions. Scale slightly to keep the edge rounded. I will scale it down just a little. Nothing should feel mechanical or repeated. I will lift this area slightly. All right, one more area to refine. Don't forget the inner ring. Glaze also flows inward toward the hole. Press Alt, then H to reveal the hidden mesh. Select a vertex along the inner edge. Press G and pull it downward slightly to begin forming a soft inner drip. Maybe lift a nearby vertex just a bit, introducing gentle variation. Treat this area the same way as the outer edge. As long as nothing blocks it, glaze flows downward naturally. Select a vertex, press G to move it slightly. Scroll your mouse wheel to adjust the size. For longer inner drips, select adjacent vertices. Press E, then Z, and extrude downward. Select, extrude, place intentionally. And just like before, introduce subtle variation. Let gravity guide the form. Select adjacent vertices. Press E, then Z, and extrude downward. Select, extrude, place intentionally. Scale slightly to keep the edge rounded. You can scale with or without proportional editing, depending on the shape you're aiming for. Select, press G to move it slightly. Select adjacent vertices. Press E, then Z, and extrude downward. Select, extrude, place intentionally. Scale slightly to keep the edge rounded. You can scale with or without proportional editing. And just like before, introduce subtle variation. Here, maybe this vertex comes up a bit. Once you're finished, pause and evaluate the silhouette. The glaze now feels uneven, layered, and visually interesting, like real icing slowly sliding down a freshly baked donut. That's looking really strong. In the next part, we will continue refining the model and push it closer to the final form. Whenever you're ready, I will see you in the next video. Welcome back. In this section, we're going to push the realism much further. Up to this point, the primary forms are working. The glaze already reads as believable, but realism lives in subtle detail. Now we'll focus on microsurface variation, tiny pores, soft irregularities, and thickness changes in the glaze. These are details you don't consciously notice at first, but if they're missing, the model feels artificial. We'll also refine how gravity affects the glaze, especially near the base of the drips. When this behavior feels correct, the donut stops looking like a clean 3D asset and starts feeling real donut. Alright, let's begin with thickness variation. Real glaze is never uniformly thick. It pools across the top, then stretches thinner as it flows toward the edges and drips. To recreate that, we'll use vertex groups and weight painting. Go to the Object Data Properties tab, the green triangle icon. Under Vertex Groups, click the plus button to create a new group. Then give it a clear name, something like Thickness Weight. This group will store weight values that control how strongly the Solidify modifier affects different areas. Now switch from Object Mode to Weight Paint Mode. You can use the drop-down in the top left, or press Ctrl-Tab and choose Weight Paint. The glaze will turn blue. Blue means zero influence, no additional thickness. Before painting, set the weight value to 1 and the strength to 1. We want full intensity for the heaviest areas. Now begin painting the very top center of the glaze in red. Red means full influence, maximum thickness. Move slowly. Observe the surface. Think about where glaze would naturally gather, where it would be deepest and slowest to move. The top center usually carries the most mass. Paint around the ring, keeping it consistent. Next, paint the base of each drip in red. Focus on the connection point where the drip meets the main glaze layer. These are anchor points, where glaze pools before gravity pulls it downward. Work around the donut patiently. Keep your brush controlled. If it feels too large, reduce the radius slightly. I prefer maintaining a consistent brush size so long and wide drips feel cohesive. For now, don't worry about absolute precision. We can refine later. Next, lower the strength to around 0.2. Now paint the tips of the drips with a lighter color, closer to blue or light green. These are the thinnest areas. In real life, these stretched tips would appear slightly translucent. Think in gradients, thick at the top, gradually thinning as the glaze flows downward, lightest at the tips. That smooth transition is what makes this convincing. Move around the surface and introduce soft green areas, a middle range between red and blue. Avoid harsh transitions. We want subtle blending. Now, reduce the weight value even further, and slightly reduce the brush size. If you notice paint where it doesn't belong, gently remove it. This process is flexible. You paint, you observe, you adjust. If your initial brushwork was already controlled, you may not need much correction. There's no need to overwork it. If you see sharp color boundaries, lightly brush over those transitions to soften the gradient. If it already looks smooth, leave it. Once the painting feels balanced, return to the Modifiers tab. In the Solidify modifier, locate the Vertex Group field. Select Thickness Weight from the drop-down. Switch back to Object Mode using Ctrl-Tab. Now the Solidify thickness is driven by your weight paint. Red areas receive full thickness, blue areas receive almost none. Everything in between transitions proportionally. Adjust the thickness value itself. Start around 0.04, then test values up to 0.06. Watch how the glaze updates in real time. In my case, 0.04 feels right. Yours may differ slightly. Just observe how the surface responds. This variation becomes especially important later when we add materials and transmission. Thinner areas will allow more light to pass through, creating that subtle wet translucency. Thicker areas will feel denser, closer to opaque sugar. Once the glaze feels balanced, not too thick, not too thin, you could apply the Solidify modifier. but I recommend keeping it unapplied for now. We'll be adding additional modifiers, and modifier order matters in Blender. When everything is finalized, we'll apply them in the correct sequence to preserve the result we want. Alright, the glaze also needs surface texture. Right now, it's still a little too clean, too uniform, almost plastic. Real glaze have tiny sugar grains, small cracks, and subtle unevenness. So let's build that noise texture into the surface. To do this, we'll use the Displace modifier. Unlike shading tricks, displacement actually moves geometry. It pushes vertices in and out using a texture, which gives us true 3D surface detail, air bubbles, and gentle cracks. Before adding it, check your mesh density. If the geometry is too low, displacement will look faceted. Make sure your subdivision surface modifier is set to at least viewport level 2. Click Add Modifier, and under Deform, choose Displace. At first, the donut may distort in a strange way. That's normal. There's no texture assigned yet, so Blender is displacing the surface blindly. Let's fix that. In the Displace modifier, click New to create a texture. Then go to the Texture Properties panel. Change the texture type to Noise. Noise works well here because it creates natural, organic variation, perfect for sugar grain. Back in the Displace settings, set the mid-level to 0.5, then lower the strength significantly. Start around 0.003. That's usually enough. You should now see subtle pores forming across the surface. If it feels too aggressive, reduce the strength slightly. With displacement, small values make a big difference. Now, real surfaces have layered detail. There are fine pores on top and broader, softer variation underneath. So let's add a second Displace modifier below the first one. Create another noise texture. This time, set the mid-level slightly higher, around 0.7. Keep the strength around 0.003. This second layer introduces larger, softer bumps beneath the fine pores. Together, these two layers create complexity, just like real sugar glaze texture. That's working well. Press Z and switch to Rendered View to preview the result. Take a moment to evaluate it. The surface should now feel tactile, not perfectly smooth. To soften any harsh edges, add a Smooth modifier. This gently relaxes the geometry without removing the displacement detail. Now let's address one more thing. Temporarily hide the Solidify modifier so we can focus on the base mesh. If you notice slight separation or clipping between the glaze and the donut, we can correct that, adding another modifier. Click Add Modifier. Under Deform, choose Shrink Wrap. And remember, modifier order matters. Blender evaluates modifiers from top to bottom. Think of it as stages. First, define the shape, then position it correctly, then refine and smooth it. For the glaze, the order should flow logically. Place Shrink Wrap so it targets the base donut. Use the eyedropper tool to select the donut object. This ensures the glaze conforms cleanly to the surface. After that, Solidify handles thickness. Subdivision smooths the result. Once everything looks correct and you're confident in the structure, you can apply the modifiers in the proper order. And just like that, your donut now has believable surface texture and natural thickness. Now, to refine the glaze for more realistic details, we need to introduce a few additional sculpting tools. So at this point, we'll switch from Layout to Sculpt mode. On the left side of the screen, you'll see the Sculpting Brush panel. These brushes behave very much like real-world sculpting tools. Some brushes add volume, some smooth the surface, others push or pull the mesh. For this stage, we'll focus on just a few essentials. But before we sculpt anything, there's one technical detail we need to address. Even though we added a subdivision modifier earlier, Blender does not automatically apply it for sculpting. So if your glaze still has an unapplied subdivision modifier, switch back to Object mode and apply it. This gives us the additional geometry we need. Also, temporarily disable the Displace modifier in the viewport. This will make sculpting much more responsive. Alright, once that's done, return to sculpt mode. Here, we'll concentrate mainly around the bases of the drips and along their outer edges. These areas carry most of the visual weight. It's where glaze naturally gathers under gravity. The first brush we'll use is the inflate brush. Press I to activate it. To adjust brush size, press F and drag your mouse to scale the circle. And if you ever forget a shortcut, you can always select the brush manually from the list above, or even down here. When you hover over each icon, Blender shows the brush name, guiding you back. The inflate brush does exactly what the name suggests. It adds volume to the surface. We'll use it to build thickness where glaze would realistically accumulate. Start near the base of each drip. Work slowly. Observe the surface as you go. Some drips should feel heavier, others slightly thinner. That variation is important. Nothing should look identical or patterned. Keep most of your inflate work close to the drip bases. This creates a believable gravity effect instead of flat, uniform drip ends. Gently build up the base of each drip. Not too much, just enough. Sculpting can feel repetitive. It takes patience. And that's exactly why this donut is more complex than it appears. Small details make the difference. Every subtle adjustment adds realism. Try to enjoy this stage. We're not just shaping geometry. We're studying how real materials behave and translating that into form. All right, that's looking good. You can already see the difference. The glaze feels slightly melted now, and that is exactly what we're aiming for. Next, we'll create the thicker glaze lip around the outer edge of the donut. If you've looked closely at a real glazed donut, you've probably noticed that before the glaze drips, it builds up into a subtle ridge along the rim. That small buildup adds a surprising amount of realism. So let's recreate it. To begin, activate the mask tool. Press M. Set the brush strength to 1. Adjust the brush size so it matches the thickness of the ridge you want to form. Not too wide, not too narrow. Keep it proportional. By default, Blender paints through the mesh and affects the backside as well. We don't want that. In the brush settings, enable front faces only. Now you'll only affect the visible surface. If the view feels cluttered, press the / key to isolate the glaze. It makes the process cleaner. Alright, carefully paint along the outer rim of the icing. Move slowly and follow the edge where the glaze meets the air. Avoid areas where the glaze is already dripping downward. Those sections already have enough weight. The mask brush requires precision. Take your time here. It's better to work carefully now than to correct inflated mistakes later. Even if the mask looks fine at first, you may notice issues once we inflate. A slightly misplaced mask can create an unnatural ridge. This often happens if you accidentally paint over the sides of a drip. Even a small masked patch there becomes obvious after inflation. So prioritize accuracy over speed. That section needs a quick correction. Let me repaint that area. The darker masked region you see is the part of the mesh that will remain protected. This section, just a little adjustment. That looks better. Once you've completed the full rim, press Ctrl-I to invert the mask. Now only the rim area is editable. From the toolbar, choose Mesh Filter and set the filter type to Inflate. Lower the strength to around 0.1. We want a controlled adjustment. Click and drag slowly. Dragging to the right inflates the rim. Dragging to the left deflates it. Increase gradually and watch the edge rise. You'll see the glaze become thicker, heavier. Yes, that's working nicely. That subtle ridge instantly improves realism. It feels like the glaze has settled naturally. Now clear the mask. Go to Mask and choose Clear Mask, Clean Surface. To finish shaping the glaze, we'll soften any remaining sharp transitions. bring the donut base back into view by pressing the / key again. Activate the smooth brush. Press S. Before you begin, rotate the donut slowly. Inspect the glaze lip from multiple angles. Set the strength very low. Increase the brush radius slightly. You can press F to adjust the size. Now make one gentle pass across the rim. Maybe slightly larger. Yes, that's better. Move around the donut and soften any harsh edges. Blend gently around the drips, especially where transitions feel too rigid. Alright, now reduce the brush radius again. Refine around individual drips. Soften transitions without flattening the form. We're not removing structure, we're just easing sharp geometry. Focus near the area where longer glaze trails separate from the surface and begin to flow downward. Avoid sharp breaks in this region. Continue rotating the model and smooth wherever needed. Blender allows infinite detail, but restraint is just as important. Every stroke should have intention. Now take a look. The glaze feels more fluid, more natural, less geometric. This is the point where a simple shape becomes believable. And that completes our sculpting stage. Press Z and return to object mode. Re-enable the displace modifier in the viewport. Take a moment to rotate the donut. View it from different angles. You've added far more refinement than it might seem at first glance, and that's something to appreciate. We now have a properly modelled, well-detailed, realistic glazed donut. Great work. In the next part, we'll add sprinkles and push this closer to the final result. If you're ready, I'll see you in the next video. And before you head out, don't forget to subscribe. It really supports the channel and helps me keep creating tutorials like this. If this lesson helped you, feel free to leave a like or a comment. It makes a real difference. All right, I'll see you in the next one. Welcome back. The time has finally come to decorate our delicious-looking donut with sprinkles. This is usually the moment where the donuts start to get really fun. Sprinkles are purely decorative, but they give the donut personality. To build this, we're going to use one of Blender's most powerful systems, geometry nodes. Geometry nodes let us generate and control geometry procedurally instead of placing every object by hand. That means we can manage the number of sprinkles, their placement, their scale, and their randomness, all from one clean, flexible setup. And just so you know, this is exactly how production environments handle scattered detail like grass, debris, or crowd elements. No one is manually placing thousands of objects. This is real-world workflow. Alright, let's get started. Go up to the Workspace tabs at the top of Blender and switch to Geometry Nodes. If you don't see it immediately, click and drag across the tabs with the middle mouse button to scroll sideways until it appears. Then select it. On the left side, you'll see the Spreadsheet panel. We won't need that for this setup. Right-click between the editors, choose Join Areas, and collapse that panel. This gives us more room for the node graph, which we're definitely going to need. Now select the icing object on your donut. If it's off-screen, press the tilde key and choose View Selected to frame it in the viewport. With the icing selected, click New in the Geometry Nodes panel. This adds a Geometry Nodes modifier to the object and creates a basic node tree. On the left, the Group Input node represents the original icing geometry. On the right, the Group Output node represents the final result. Right now, nothing changes in the viewport, and that's completely normal. There's no operation happening between those two nodes yet. Our job is to build a system between them that generates controlled surface detail. Alright, let's start placing sprinkles. Before anything can sit on the glaze, Blender needs a way to determine where objects should be placed, and that starts with points. Think of points as tiny invisible pins distributed across the surface of the icing. Later, each one of those pins will become a sprinkle. Press Shift-A to open the Add menu. Go to Points and choose Distribute Points on Faces. Now insert this node between the group input and the group output. When you hover over the connection line, you'll see it highlight slightly. Click to drop the node into the link automatically. And now, you'll notice something unexpected. The icing disappears, and all you see are points. That's because Blender is currently outputting only the points. It assumes that's all you want to see. But we don't want to replace the mesh, we want to add to it. So let's fix that. Press Shift-A again and add a Join Geometry node. Place it after the Distribute Points node. Now take the original geometry output from the Group Input node and plug it into the Join Geometry node as well. And there we go. The icing mesh is visible again, and the points remain on the surface. Perfect. Now we have a clean procedural foundation, ready to turn those points into sprinkles. Right now though, those points don't exist in the render. They're just placeholders, data points in the system. To make them visible, we need to instance real geometry on top of them. In our case, sprinkles. So let's build the sprinkle models first. Switch over to the Layout workspace for a moment. Whenever you add a new object in Blender, it appears at the location of the 3D cursor. So let's move the cursor off to the side. Hold Shift right-click and place it somewhere to the left. If you're not using a mouse, you can activate the cursor tool. It does the same thing. Alright, press Shift-A, go to Mesh, and add a cylinder. Immediately reduce the vertices to around 12. We want these to stay lightweight. Set the radius to about 0.02 and the depth to 0.04. Now move the sprinkle upward slightly so it sits above the Z-plane. Frame it up close. Press the tilde key and choose View Selected. If you zoom in and the object disappears, that just means it's very small and the viewport is clipping it. To fix that, press N to open the side panel. Go to the View tab and lower the Clip Start value. That should make it visible again. Just double check yours. Mine looks good. Enter Edit mode. Scale the sprinkle slightly along the Z-axis to elongate it a bit. This will be our short sprinkle. Right now the edges are sharp, almost like a tiny metal pin. Real sprinkles have soft, rounded ends, so let's clean that up. Switch to Face Select mode. Select the bottom face, then Shift select the top face. Press Ctrl-B to bevel. Scroll your mouse wheel to add a few segments. And just like that, we've got smooth, rounded tips. Much better. Alright, we have our first sprinkle. But real sprinkles aren't identical. Variation is what makes them believable. So let's duplicate it. Press Shift-D, then press X to move it along the X-axis. This will be our medium sprinkle. Enter Edit mode, turn on Wireframe, and switch to Vertex Select. Select the top vertices, press G, then Z, and move them upward slightly. If proportional editing is enabled, turn it off for now. Good. Duplicate it again. Shift-D, move it along X. This will be the long sprinkle. Go into Wireframe, select the top vertices, press G, then Z, and extend it a bit more. Nice. Now let's add something less perfect, because in real life, sprinkles aren't perfectly straight. Duplicate one more time and move it along the X-axis. With this one selected, enter Edit mode, press Ctrl or to add a loop cut. Scroll the wheel until the faces are more evenly distributed, then confirm. Go to the modifier panel, add a modifier, and choose Simple Deform. Change the mode from Twist to Bend. Set the angle to around 60 degrees. If the bend looks off, it's usually because of the object origin. So select all the sprinkles, right-click, and choose Set Origin, Origin to Geometry. That aligns everything properly. Now apply the modifier on the bent sprinkle. And there we go. Short, medium, long, bent. They're subtle differences, but together they add a lot of realism. Before we move on, let's organize the scene. It might feel like housekeeping, but keeping things clean makes everything easier later. Go to the outliner and create a new collection. Rename it Sprinkles. Select all the sprinkle objects, press M, and move them into the Sprinkles collection. One more thing, the shading looks a little faceted. Select the sprinkles, right-click, and choose Shade Smooth. There we go, clean geometry, nice variation, ready to be scattered. Alright, back to the node setup. Select the icing again. If the Geometry Nodes editor switches away when you click another object, click the pin icon at the top of the editor. That locks the node tree so it stays visible no matter what you select. Now give yourself a little breathing room in the graph. Just drag the nodes apart so we have space to build between them. Next, we need to tell Geometry Nodes which sprinkles to use. Go to the outliner, grab the Sprinkles collection, and drag it directly into the Geometry Nodes editor. When you release it, Blender automatically creates a Collection Info node. Perfect. Press Shift-A, go to Instances, and add Instance on Points. Place it between Distribute Points on Faces and Join Geometry. Now connect the geometry output of the Collection Info node into the instance input of Instance on Points. You'll see them appear immediately. Make sure all 3 collection checkboxes are enabled inside the Collection Info node. As soon as that's active, the sprinkles scatter across the icing. Nice. Now press Shift-A again, go to Instances, and add Realize Instances. Place it between Instance on Points and Join Geometry. This converts the instanced sprinkles into real geometry, which gives us more control later. Now increase the density value in the Distribute Points on Faces node. Higher density, more sprinkles. But you'll notice they begin overlapping. That's because the distribution method is currently set to random. Change the distribution type from random to Poisson disk. Poisson disk spacing maintains a minimum distance between points. Now adjust distance min. If the value is too small, the sprinkles intersect. Our sprinkles are tiny, so we can push density fairly high. Slowly increase distance min while watching the surface until the intersections disappear. There we go. Clean spacing, natural scatter, no collisions. Now look at the sprinkles. They're all standing straight up. That's not how sprinkles behave. They settle onto the glaze. So let's correct the orientation. Go to Distribute Points on Faces. Drag the rotation output into the rotation input of Instance on Points. Now the instances inherit the surface orientation. Better, but our original sprinkle models were built upright, so we need to rotate the actual sprinkle objects. Select all the sprinkle objects in the scene. Press OR, then X, type 90 and press Enter. Now apply that rotation. Press Ctrl A and choose Apply Rotation. Much better. Now they rest naturally on the icing. Next, rotation variation. Uniform rotation always looks artificial. Press Shift A, go to Instances and add Rotate Instances. Place it between instance on points and realize instances. In the Rotate Instances node, enable local space. That's important. Each sprinkle should rotate relative to itself. Now drag from the rotation input and add a random value node. For the maximum values, set Z to 2 pi, set Y to 2 pi. You can type tau, Blender understands it. For X, set the max to 0.5. This gives full rotation along the surface with a slight tilt variation. Nice. Now let's introduce scale variation. Drag from the scale input of instance on points and add another random value node. Change the data type to float. If it disconnects, plug the output back into the scale input. Set the min to 0.8 and the max to 1.2. Subtle size variation like this adds a surprising amount of realism. Finally, go back to distribute points on faces and fine-tune distance min. Around 0.006 works well here. You can also slightly lower the pivot offset, around 0.003, so the sprinkles rotate more naturally around their center. Take a look now. They're lying down. They rotate randomly. They vary in size. They're not intersecting. That's a solid procedural scatter. Now go full screen for a moment and really observe the result. You'll notice something. Sprinkles are distributed everywhere, even underneath the icing. That's not convincing. Real donuts don't have perfectly even distribution. Some areas are packed, others are sparse. That irregularity is what makes them believable, so we're going to control that using weight paint. With the icing selected, switch back to the Layout workspace. Go to Object, Data Properties, and add a new vertex group. Rename it something clear, like Sprinkle Density. Now switch to Weight Paint mode. The mesh turns blue. Blue represents zero weight, no influence. Here's the idea. Weight paint allows us to paint values between 0 and 1 directly onto the mesh. Later, geometry nodes will read those values to control sprinkle density. Blue means no sprinkles. Red means full density. Everything in between creates a gradient. Make sure brush weight is set to 1 and strength is also at 1. Start painting red across the top center of the icing. That's typically where sprinkles collect the most. Work your way outward. Build variation. From this point on, the distribution is in your hands. You decide where it's dense and where it falls off. This is where technical setup meets artistic choice. Think about how sprinkles land in real life. They cluster, they miss spots, they build up toward the center. If you prefer heavier coverage on top, push more red there. If you want subtle fall off near the edges, ease it back. Hold control while painting to subtract weight if you go too far. Avoid symmetry. Perfect balance usually looks artificial. Take your time here. Move around the model. Adjust as you go. This part isn't about precision, it's about observation. When it feels natural, it usually is. Alright, that looks good. Now head back to geometry nodes. Make sure you're in object mode. On the Distribute Points on Faces node, drag from Density Factor and add a named attribute node. In the name field, type Sprinkle, or whatever you named your vertex group. The name has to match exactly. As soon as you connect it, the distribution updates. Now the sprinkles follow your paint. Dense where it's red, gone where it's blue. That's already much more believable. One last thing, and this adds a lot of flexibility. Let's create variation between donuts. Duplicate the donut. Select the icing, then shift-select the donut base. Press Shift-D and move the copy along the Y-axis. Now we have two donuts. We don't want both of them to share the exact same sprinkle density, so we'll expose a parameter to the group input. Pick a value you'd like to control per object, for example, overall sprinkle density. Drag that input into the group input node to expose it. You'll now see that parameter in the Geometry Nodes modifier panel, which means each donut can have its own value. Set one donut to around 150 density. That's your Krispy Kreme for a moment. Set the other to 0. That's your clean glazed donut. Same node system, same structure, completely different results. That's the strength of geometry nodes. Once you understand the logic, you can build systems that are reusable, adjustable, and production ready. Before we wrap up, let's step back and look at the full workflow. Not just what we did, but why it works. Because this setup isn't about randomly adding nodes and connecting wires. It's about how information flows. Everything begins with group input. That node represents the icing exactly as it exists in the scene, untouched, no manipulation. It's the foundation. From there, the geometry flows into distribute points on faces. This is where the mindset shifts. We stop thinking in terms of meshes and start thinking in terms of points. The surface becomes a field of potential. Each point is not a sprinkle yet. It's a placeholder, a location waiting to become something. When we switch to Poisson disc, the distribution becomes controlled. Points respect spacing. They maintain distance. That single decision is what prevents chaos and creates believable scatter. Then density stops being a static value. Through the named attribute node, the system reads the vertex group painted directly onto the icing. Now the surface drives the distribution. Red areas produce clusters, blue areas stay clean. The mesh itself influences the result. That's where art direction enters the system. Once the points are defined, the workflow shifts from where to what. The collection info node brings in our sprinkle models. By instancing them, Blender keeps everything lightweight, even with hundreds of pieces. Instance on points replaces every point with a sprinkle from the collection. Each instance inherits position, orientation, and scale from the surface. Then we introduce variation. A random value node controls scale, subtle differences that break repetition. Another random value feeds into rotate instances, adding rotation in local space, so each sprinkle turns independently. And because we pass the surface rotation forward, the sprinkles sit naturally on the glaze. They feel grounded. Up to this stage, everything is still procedural instances. Before the final output, the system runs through realize instances. This converts the instances into real geometry. Now they respond fully to shading, lighting, and rendering. Finally, join geometry merges the original icing with the generated sprinkles. Nothing replaces the base mesh. It's all combined into a single result. And group output delivers the finished surface. It looks handcrafted, but it's driven entirely by structure and logic. This isn't just about sprinkles. This is procedural modeling for detail, for variation, for control. And once this clicks, you can apply the same thinking to anything: foliage, debris, surface breakup, even complex environmental systems. That wraps up sprinkles and our introduction to geometry nodes. Nice work. Next, we need something for the donut to sit on. Go back to the layout workspace. First, let's reset the 3D cursor to the origin. Go to the Object menu, Snap, Cursor to World Origin. Just for a moment, we'll remove one of the donuts. We'll bring it back shortly. Working with fewer objects makes positioning cleaner and faster. Select the icing, then Shift-select the donut base and press X to delete. Now we're working with a single donut, much easier to manage. Press Shift-A, go to Mesh, and add a plane. If something strange happens and the plane appears inside the sprinkles collection, that means the collection was active. Geometry nodes will read anything in that collection as potential instances, so delete the plane. In the outliner, select the default collection so the plane goes there instead. Now again, Shift-A, Mesh, Plane. Press S and scale it up so the donut has plenty of room around it. Think of this as our countertop or tabletop surface. Scale it up a bit more, just enough to frame the composition comfortably. Now let's place the donut on the surface. If you select the donut base and move it upward, you'll notice something immediately. The icing stays behind. That separation isn't correct. We need the icing to follow the base. This is where parenting comes in. Parenting allows one object to inherit the transform of another. It keeps related objects connected and organized. Here's the correct order. First, select the icing. Then hold Shift and select the donut base last. Selection order matters. The last selected object becomes the parent. Now press Ctrl-P and choose Keep Transform. Good. Now move the donut. Press G, then Z, and raise it until it rests on the countertop. The icing follows perfectly. No separation, everything stays aligned. That's exactly what we want. Now let's model the ceramic plate. Before modeling, it helps to load a reference image. Even for simple objects, a visual reference keeps proportions accurate. Move your cursor to the top edge of the viewport until you see the double arrow icon. Right-click and choose Vertical Split. In the new panel, change the editor type from 3D Viewport to Image Editor. Now open your plate reference image. The plate itself is actually very simple to model, but here I want to demonstrate how to load and use reference images while modeling. This becomes extremely important when you're working with more complex objects, where accurate visual guidance makes a big difference. And by the way, if you want to use the exact same reference image, you can find the download link in the video description. Alright, let's build it. Press Shift-A, go to Mesh and add a circle. In the Settings panel, set the vertices to 100. Increase the radius to about 2.3. This gives us a smooth circular base without unnecessary density. Enter Edit mode and switch to Vertex Select. Press E, then Z, and extrude upward slightly to create the beginning of the plate's rim. Press S and scale outward just a bit to suggest that subtle outward curve. Once that shape feels right, select the bottom edge loop and press F to fill it. Good. Now let's soften the sharp transition. Press Ctrl-B to bevel. Scroll the mouse wheel to add segments and pull it outward near the lip. That instantly removes the hard edge and gives it a more ceramic feel. Next, we'll give the plate thickness. Switch back to Object mode. Go to the Modifiers tab and add a Solidify modifier. Set the offset to 1. Set the thickness to 0.006, just enough to make it solid without feeling heavy. Apply the modifier. Now let's refine the outer rim. Go back to Edit mode and switch to Edge Select. Select one edge loop. Then hold Alt-Shift and select the second edge loop. Press Ctrl-B again to bevel. Now press C to enable Clamp Overlap. This is important. Clamp Overlap prevents geometry from intersecting itself. It limits the bevel when edges begin to meet. Click to confirm. Nice. The form feels much cleaner. We can close the reference panel now. Right-click on the divider and choose Join Right. One final cleanup step. When using Clamp Overlap, Blender sometimes leaves overlapping vertices. You won't see them, but they're there. Go into Edit mode, press A to select everything. Press M and choose Merge by Distance. Blender will now find and remove any duplicated vertices. You see 100 overlapped vertices are removed. Now smooth the plate. Switch to object mode, right-click and choose Shade Smooth. Much better. If the bottom of the plate slightly intersects the countertop, move it up just a little. This prevents rendering artifacts later. I let the donut rest on the plate. The proportions feel balanced. The topology is clean. Nice work. In the next part, we'll move into materials and textures, refining the icing, the sprinkles, the ceramic plate, and the countertop to bring the entire scene together. I'll see you in the next part. Welcome back, my families. Up until now, everything we've built has been about form, pure shape. But this is the moment where the donut stops looking like an object and starts to feel like food. Now, we move into materials and texture. And honestly, this stage matters more than most beginners realize, because this is where we shift from geometry into appearance, from something you can rotate into something you can almost taste. This is where we start understanding why food feels appealing in the first place, how light rolls across a surface, how different materials respond to that light, and how we recreate that same visual behavior inside Blender. All right, let's begin. Go up to the top workspace tabs and switch to Shader Editor. This is where we build and control our materials, before we think about final lighting or world rendering. By default, you'll notice the scene is already lit. That's because Blender is using an HDRI and material preview mode. This light isn't coming from our scene yet. It's just a preview environment so we can clearly see how the material responds. If you'd like, you can switch to a different HDRI from the drop-down at the top of the viewport. These are Blender's built-in preview HDRIs, designed specifically for evaluating materials. Later, you can load your own custom HDRI and fine-tune it to match whatever lighting mood you're building. But for now, this neutral setup is perfect. It lets us focus entirely on building the material itself. Before moving forward, let's clean up the shader editor layout. If you see extra panels open, hover over the divider line, right-click and choose Join Areas to remove them. Leave yourself with a single clean shader workspace. Now, here's something important. A 3D model without materials is just geometry. It has shape, but no surface behavior. Materials define how light interacts with that surface. They decide whether light reflects softly or sharply, whether it sinks in or spreads across the surface. In other words, materials define how a surface reflects, absorbs, and scatters light. You don't need to memorize the physics behind it. What matters is developing a visual instinct when something feels believable or when it doesn't. So what we're doing now is training that visual instinct. We'll build the soft bread texture of the donut, then the glossy sugar glaze. After that, the chocolate glaze, and finally, the sprinkles. As we go, pay attention to how the surface reacts, how small adjustments can shift realism dramatically. Because realism doesn't come from perfection, it comes from observation. All right, let's start with the donut base. Select the donut base, then click New Material. Blender automatically assigns a principled BSDF shader, and that's exactly what we want. Make sure your material is using principled BSDF. If it isn't, you can switch it from the shader dropdown. The principled shader is designed to handle most real-world materials in a single node. That's why it's industry standard, perfect for building real surfaces. Now focus on the node setup. You'll notice the material settings panel on the right and the node on the left are connected. Any value you adjust in the material properties updates the principled node directly. They're linked. Let's start with base color. Choose a warm yellow-orange tone. Not too saturated, not too bright. Think about baked dough, that soft golden tone you see when bread comes out of the oven. That's the direction. This isn't the final look, it's just the foundation. Next, move down to roughness. Roughness controls how tightly light reflects off the surface. Low roughness means sharp reflections, which reads glossy, almost wet. Higher roughness breaks those reflections apart. Light scatters more, and the surface feels matte and organic. For bread, we don't want gloss. We want softness. Set the roughness to around 0.55, right there. That keeps it slightly porous, not dry, not shiny, just natural baked dough. Now adjust specular. Specular controls the overall strength of light reflecting off the surface. Not mirror reflections, just how much light presence the surface has. Set specular to about 0.35. That's enough. We're not trying to make it reflective, we just want a subtle light response. And already, that feels better. A donut base that looks soft, lightly porous, like it's been freshly baked. Next, let's duplicate one more donut. This one will become our glazed donut. Select the donut base, then Shift-select the icing. Press Shift-D to duplicate. Move this new copy slightly to the left, just like that. Shift the original donut a bit to the right. Just make sure they aren't intersecting. Now scale the plate slightly so both donuts sit comfortably. Give them breathing room. All right, select the glaze on the duplicated donut. Go to the Modifier tab. Set the sprinkles density to 0 for now. Then head back to the Material tab. With the glaze object still selected, add a new material. Now, before we start adjusting sliders, let's pause for a moment. And I mean really pause here. Sugar glaze, real sugar glaze, is a little tricky. At first glance, it feels simple. It's thin, slightly translucent, glossy. But the realism doesn't come from surface shine alone. It comes from how light travels through it, how it bends slightly, scatters inside, then reflects back out. This material is less about surface color and much more about transmission and surface response. Now switch to rendered view mode just for a moment. You'll probably notice the donut looks flat, maybe even dull. That can feel confusing at first. Nothing is wrong. Right now, we haven't built a proper lighting environment. The only light in the scene is that single point light. And honestly, it's not doing much. It's too weak and too isolated to describe how this material should behave. Think about sugar glaze in real life. It never exists in isolation. It's surrounded by light. Light from the sky, light bouncing off walls, light reflecting from nearby surfaces. All of that wraps around it. So if we want realism, we need an environment that supports it. Only then can we judge the material accurately. In Material Preview, we're working differently. Material Preview uses an HDRI environment to approximate how the surface reacts. It's not final lighting. It's a controlled preview. It helps us establish base color, roughness, and reflection before we commit to full lighting. And it does that job well. But it's still simplified. It doesn't fully simulate deeper effects like light transmission through glossy surfaces or subsurface scattering in organic materials. Those effects are important for sugar glaze. Without strong light interaction, the material will always feel incomplete. Material Preview behaves closer to EEVEE, fast, responsive, simplified. When it's time to render, Blender gives us two main engines in the render properties, EEVEE and Cycles. EEVEE is fast. It's ideal for modeling, animation, and interactive material development. That's why most artists begin there. But EEVEE doesn't calculate light transport with full physical accuracy. And that's fine. In EEVEE, we're not chasing perfect physics. We're balancing realism with performance. So instead of true transmission, we rely on strong specular response, clear coat layering, and roughness variation to sell the illusion. Even if EEVEE can't produce a physically perfect glaze, we can still build a convincing foundation. Later, when we switch to Cycles, we'll refine this same material and let real light physics elevate it. That's how production workflows operate. You build something believable first, then you refine it when the renderer allows you to. If the difference between EEVEE and Cycles feels abstract right now, don't worry. We'll go deeper into both rendering engines when we reach the lighting and rendering stage. For now, focus on the surface. Alright, back to the glaze. For base color, choose a soft off-white sugar tone. Not pure white. Think melted sugar, slightly warm, slightly creamy. Now adjust roughness. A fresh glazed donut has noticeable shine, but it's not glass. Set roughness to around 0.18. That gives us a clean sheen without turning it into plastic. Next, IOR, Index of Refraction. IOR controls how light bends inside the material. For food surfaces, it usually falls between 1.3 and 1.5. Sugar sits around 1.45. Now, adjust specular. Specular controls how strongly the surface responds to reflections. Set specular to about 0.55. Next, clear coat. Think of clear coat as a thin, glossy layer sitting on top of the glaze. Set clear coat to 0.35. This creates that extra reflective layer you often see on real sugar glaze. Then, adjust clear coat roughness to around 0.08. Even that top layer shouldn't be perfectly sharp. Take a look. Even inside Eevee, this is starting to read as sugar glaze. Is it physically perfect? Not yet. But as a base, it's solid and believable. That's exactly where we want to be at this stage. Now let's introduce surface variation. Here's something important. Roughness is never perfectly uniform in real life, especially with sugar glaze. Some areas are slightly wetter, some are a little drier. Some catch sharper highlights, others diffuse them. That subtle inconsistency is what sells realism, particularly in Eevee. Instead of feeding a single value into roughness, we'll break it up. Drag from the roughness input on the principled BSDF node. Add a color ramp node. Then press Shift-A, go to Texture, and add a noise texture. Connect the factor output of the noise texture into the color ramp. Now the color ramp output goes into roughness. What we're doing is controlled variation. Some parts of the glaze will be slightly smoother, others slightly rougher. Now, let's refine that variation. Look at the color ramp. The noise texture creates the pattern of variation. The color ramp controls how strong that variation becomes. Move the black handle to around 0.1. This limits how dark the pattern can get and prevents harsh contrast in the roughness. Move the white handle to around 0.3. Real sugar glaze has very subtle irregularity. We're compressing the range to keep it delicate. Now adjust the noise texture. Set scale to 18. Scale controls the size of the surface variation. If the value is too low, the bumps become large and obvious. If it's too high, the texture starts to look noisy. For glaze, we want fine micro variation. Set detail to 6. Detail increases complexity inside the noise pattern. Too much detail makes it harsh. We just need enough complexity to break the smooth plastic look. Then set noise roughness to about 0.45. This softens the internal contrast of the noise pattern. Now a quick note, especially when working in Eevee. You might be tempted to enable transmission or subsurface scattering. They sound physically correct, and in theory, sugar glaze does involve light passing through the surface. But in Eevee, these features often make the material look less convincing. Instead of adding realism, they make the material appear artificial. So for now, we leave them off. Later, when we switch to cycles, we'll introduce transmission and subsurface properly. Under real light simulation, they'll finally behave the way we expect. Right now, we're building foundation. In production, materials aren't finished in one pass, not because we can't, but because we work in layers. First, a controlled base, then refinement under proper lighting, then physical accuracy where it matters. That's a professional shader workflow, and this approach isn't just about donuts. After this series, you'll build larger scenes, more complex assets, heavier environments. Those projects demand performance and structured thinking. That's why we're using a glazed donut. It looks simple, but it teaches shader control, lighting discipline, production workflow. This is real 3D practice. Trust the process. Later on, you'll understand exactly why we built it this way. Now, let's build the material for the Krispy Kreme chocolate glaze. Select the chocolate glaze first. Temporarily set the sprinkle density to 0. We want to evaluate the surface without distractions. Alright, instead of building this shader from scratch, we're going to take a smarter approach. We'll duplicate the sugar glaze shader. Structurally, it's the same type of material. It's still glaze. It still has a glossy surface layer. The difference isn't in the setup, it's in how the surface responds to light. Press A to select all nodes. A for all, consistent across Blender. Press Ctrl+C to copy the entire node network. We're preserving the structure, we're just recalibrating it. Now switch to the chocolate glaze material. Select all existing nodes and delete them. Press Ctrl+V to paste the copied setup. Now we're working from a familiar base. First, adjust the base color. Choose a rich chocolate brown, not pure black, not too saturated. Pink melted chocolate, deep, warm, slightly soft in tone. Next, adjust roughness. Set it to around 0.22. That keeps the surface glossy, but slightly more controlled than the sugar glaze. Now lower the clear coat value to about 0.25. Sugar glaze reflects light strongly at the surface. Chocolate behaves differently. Chocolate absorbs more light. So instead of relying on heavy surface shine, we let lighting contrast define the form. Darker materials depend more on lighting direction and intensity, and once we introduce proper sunlight, this will respond nicely. Now, adjust the noise texture. Set scale to 6. Chocolate glaze doesn't have fine micro variation. It flows slowly and spreads with weight. When melted chocolate is poured, you don't see small ripples everywhere. Instead, you see broader, smoother variation. Lower scale values give us exactly that kind of surface. Set detail to 2. We keep this intentionally low. Too much detail introduces sharp breakup, and chocolate doesn't fracture that way. Now go to the color ramp. Change the interpolation from linear to ease. Chocolate transitions gradually. It doesn't shift abruptly from glossy to rough. Move the black handle to around 0.35. This reduces how extreme the rough areas become. Move the white handle to about 0.65. This pulls the brighter reflections inward, making them smaller and more focused. With just these adjustments, the material already reads differently. Same structure, different light behavior. Now let's move to the sprinkles. Before continuing, go back to the Modifier tab and restore the sprinkle density on the Krispy Kreme donut. Good. Well, create one shared material for all sprinkles. Select any single sprinkle object. It doesn't matter which one. Create a new material and name it Sprinkles. Right now, only that one sprinkle has the material, and that's correct. Now Shift-select all the other sprinkle objects. This part matters. Make sure the last sprinkle you select is the one that already has the material assigned. It will appear highlighted in yellow. That means it's the active object. Selection order matters here. Press Ctrl+L to open the Link or Transfer Data menu. Choose Materials. Now all sprinkles share the same material, which means one change updates everything. Next, switch to the Geometry Nodes workspace. This is where we'll generate randomized color variation. Press Shift-A, go to Attribute, and add Store Named Attribute. Place it right after the Realized Instances node. Change the type to Color. Change the domain to Instances. For the name field, type something like Sprinkle Color. We're defining an attribute the shader can read later. Now switch to the Shading workspace. Select one sprinkle, any one. Press Shift-A, go to Input, and add an attribute node. In the Attribute Name field, type the exact same name, Sprinkle Color. Take the color output from the attribute node and plug it into the base color of the principled BSDF. Now go back to Geometry Nodes. While you're there, change the viewport shading to Material Preview so we can clearly see the color changes. From the value input of the Store Named Attribute node, drag out and add a color ramp. Drag from the Factor input of the color ramp and add a Random Value node. Set the type to Float. At first, nothing interesting happens. That's because the color ramp is currently blending from black to white. Here's the key adjustment. Change the color ramp interpolation from linear to constant. Now each sprinkle snaps to a single solid color, no gradient blending. That sharp separation is exactly what we want. Click the plus icon to add a new color stop. Choose a soft light blue. Add another stop, maybe a soft red. Slide the ramp handle slightly and watch the distribution shift. Let's add another color, a soft yellow. Keep saturation controlled. Highly saturated colors tend to feel artificial. For something like sprinkles, aim for saturation around 0.8. Finally, add a white sprinkle. The position of each stop controls how much of the surface receives that color. Avoid perfectly even distribution. You might let one or two colors dominate, while others appear more occasionally. That's actually closer to how real sprinkles behave. Usually, one color is more common, another shows up here and there, and a few appear only in small scattered amounts. Let the ramp reflect that imbalance. Now let's finalize the surface behavior. Switch back to the shading workspace. Set roughness to about 0.4. Sprinkles shouldn't be glossy. Their realism comes from variation in color, rotation, and distribution, not from reflection. Set specular to 0.4 as well. Even though Blender allows metallic materials, real sprinkles are sugar, not metal. And that's it. Just by adjusting a few ramp stops, you've created an entire sprinkle color palette. Now, for the ceramic plate, let's assign a material. Select the plate and create a new material. For the base color, choose a neutral gray, not too dark, not too bright. Set roughness to around 0.4. That keeps the surface smooth without turning glossy. Set specular to about 0.4 as well, just enough to catch soft highlights. Then set the coat weight to 0.1. That adds a subtle top layer, helping the ceramic respond more naturally to light. Alright, that works well. Now let's move to the plane and turn it into a marble countertop. First, scale the plane up so it looks like a full countertop surface. Instead of using a flat color, we'll use an image-based marble texture. Image textures introduce real-world micro-detail, natural veins, subtle imperfections. They add a lot of realism with very little setup. Select the plane, add a new material, then open the shader editor. Click the small circle next to base color and choose Image Texture. Right now the surface turns black. That's normal. Blender is waiting for an image file, so next we'll download a texture. Open your browser and search for FreePBR. You can also find the link in the description. FreePBR provides royalty-free PBR materials commonly used in production workflows. Search for marble. Choose a white marble texture. It works best for this scene since we're aiming for a clean kitchen-style countertop. Download the Blender zip version. Once it finishes downloading, unzip the folder. Inside, you'll see multiple high-resolution maps. Some control color, others define roughness and surface detail like normals. We'll start wiring those up next. Now return to Blender. In the Image Texture node, click Open. Navigate to the folder where you extracted the marble files. Select the image that ends with albedo, then click Open. Immediately, the plane updates with detailed marble patterns. It's already an improvement, but notice, it still feels slightly flat. The reflections are too uniform. Real marble doesn't behave that evenly. To fix that, we'll connect the additional maps. Quick reminder, in the shader editor, nodes generally flow from left to right. Image textures provide data. The shader interprets that data, and the shader output becomes the final material on the object. Right now, we've only connected the color map. That's the albedo texture we just loaded. Next, we'll add the roughness map. Drag from the roughness input and add an image texture node. Open the same folder and choose the image with roughness in its name. Once loaded, change the color space from sRGB to non-color. This step matters. Roughness is not color information. It's grayscale data that controls how light scatters. If left in sRGB, the surface will respond incorrectly. Now the marble starts to develop variation. Some areas reflect light more softly, others remain slightly matte. Next, let's add the normal map. Drag from the normal input and add another image texture node. Open the image that contains normal in its name. Just like before, change the color space to non-color data. Normals represent directional data, not color. Press Shift-A, go to Vector, and add a normal map node. Connect the color output from the normal texture into the normal map node. Then connect the normal output into the shader's normal input. Now look at the surface. The marble has subtle bumps. Tiny dents and veins interact with light more naturally. Highlights break across the texture instead of sliding uniformly. Press Ctrl Space to go full screen and evaluate the surface closely. It no longer feels flat. The marble now reads as a solid, physical material. And that's our countertop material. Nice work. Now, let's add a final layer of realism to the donut itself. Go back to the Layout tab and isolate the donut by pressing the / key. This local view helps us focus entirely on the donut surface without distractions from the rest of the scene. Switch to Material Preview so we can clearly evaluate changes as we paint. If you look at real donut references, you'll notice the surface color shifts slightly because of heat and oil absorption, especially around the inner ring and along the outer edges. Those small tonal variations are what make baked food feel believable. This is where texture painting becomes essential. Before we start painting, we need to understand one core concept: UV unwrapping. Texture painting doesn't happen directly on the 3D geometry. Instead, Blender paints onto a flat 2D image. That image is then wrapped around the 3D model using a UV map. UVs are essentially layout instructions. They tell Blender how the flat image attaches to the 3D surface. Think of peeling an orange and laying the peel flat on a table. That flattened peel is your UV map. Every curve and surface section of the donut is assigned a specific area on that flat image. So when you paint on the image, it appears correctly on the 3D model. Alright, switch to the Texture Paint tab. If you try painting right away, you'll notice nothing happens. You may get a warning, Missing Textures Detected. That's expected. UVs define placement, but we haven't created an actual image to paint on yet. Go back to the Material tab. Click the small yellow dot next to Base Color and add an Image Texture node. Instead of opening an image, click New. Name it Donut Base. Choose a resolution high enough to capture fine surface detail. Set the default color to a warm yellow tone that matches baked dough. Then click OK. Make sure this new image is selected in the Image Texture node. This step matters. Now Blender knows exactly where to store your brush strokes. Every mark you paint will be written to this image file. And now we have a canvas for painting subtle color variation into the donut surface. Select the eyedropper tool and sample the donut's current base color. Then adjust that color slightly lighter. Not white, just a subtle lift. We're simulating areas where the dough baked a little more and caught extra heat. Choose a soft brush. Set strength to about 0.5, so strokes blend naturally into the surface. Now you can paint directly on the donut inside the 3D viewport. You'll see the color update immediately on the model. You can also paint inside the image editor over here. Both methods affect the same texture, so you can switch between them at any time. The image editor often gives better precision, especially near the inner ring. Start around the center. Move slowly along the inner edge. Keep the brush close to the inner edge, not too far out. Build it up slowly. you'll already start to see subtle variation forming. If some areas look slightly overpainted, don't worry, we'll blend them. Once the initial strokes are done, switch the brush type from draw to soften. Brush over any spots that appear too bright. You'll notice sharp transitions start to smooth out. Let the tool smooth the gradient. We're aiming for subtle variation, no hard edges. For the inner ring, switch to airbrush. Lower the strength to about 0.2. Now, work in the image editor. Paint over the top corners and wrap the colour into the inner ring. Build it gradually. Now switch back to a soft draw brush. Increase strength to about 0.8. This pass is for confident blending. Focus on the edges, smooth all transitions. Unify the surface. There shouldn't be any sharp breaks. Step back for a second and evaluate the result. The donut now has subtle heat variation. It feels baked. That small shift adds a surprising amount of realism. Once you're satisfied, remember, texture painting is not saved automatically. Look at the top left of the image editor. If you see a small asterisk next to the image name, the texture hasn't been saved yet. Go to Image, Save, and choose a location on your drive. This is critical. If you skip this step, all your painted detail will be lost. After saving, press / again to exit local view. Everything returns to the scene. And that completes our texture painting pass. Now, go back to the Layout tab. Before we move on, let's create a backsplash by duplicating the marble plane. Select the countertop. Press Shift-D to duplicate it, and move the copy slightly out of the way. Press or then X to rotate along the X-axis. Hold Ctrl while rotating for precise increments, or type the exact rotation value and press Enter. Now move the duplicated plane upward until its bottom edge aligns perfectly with the back edge of the countertop. And there we have it. The backsplash is in position. Next, select both marble planes and move them up together. Raise them slowly until the countertop sits slightly above the Z-axis. Now select the plate and donuts together. Press G, then Z, and lift them slightly until they rest on top of the countertop. Check the contact point. No floating, no clipping. Good. And that wraps up our materials and textures. At this point, it's worth stepping back and looking at everything together. We approached this scene by modeling first, then assigning materials across the objects. That allowed us to compare surfaces side by side. Ceramic, marble, glaze, dough, and observe how each responds to light. In larger production scenes, you might choose a different workflow. Sometimes artists fully model one asset and finish its material before moving on. That approach keeps things modular and easier to manage in complex environments. Here, the goal was clarity. I wanted you to understand how materials, texture maps, and subtle variation work together across a full scene. Once that foundation is clear, you can adapt the workflow to whatever project you're building. And seriously, well done. You've taken this donut from simple geometry to a fully textured scene with layered, responsive materials. In the next part, we'll move into lighting and shading, the stage where everything comes together under real-world light simulation. So when you're ready, join me in the next video. I'll see you there. Welcome back. This section marks a critical phase in our 3D workflow. It's also one of the most important and often one of the most challenging stages of the entire process. This is where we begin pushing the realism of our donut much closer to how a real donut behaves in the real world, especially under light, shadow, and reflections. Lighting becomes the turning point here. You can build strong materials, detailed textures, and well-modeled forms, but without proper lighting, the entire scene will still feel artificial. And that's exactly what we're seeing with our donut right now. If you look closely, the material itself is no longer the main issue, aside from the sugar glaze, which we'll refine later. The real problem is how light interacts with the surface, how it wraps around the form, how shadows develop, how highlights break across the glaze, and how contrast creates depth in the scene. So in this section, our goal is very clear. We're going to build strong, physically believable lighting and simulate how real-world light behaves across our donut material. First, let's talk briefly about what lighting actually means in a 3D workflow. Lighting is the stage where we place and control light sources and environment lighting inside the scene, so our materials and textures start responding the way they would in the real world. This is where we simulate the behavior of real light, how it travels through space, how it creates shadows, and how it reacts when it hits different surfaces. We're not simply making the scene brighter, we're illuminating it in a way that feels natural and visually readable, so every form, surface, and detail is clear to the eye. Now, let's switch to rendered view so we can see our lighting and materials updating in real time. You can change this from the viewport shading icons right here at the top. Or, for a faster shortcut, press Z and choose Rendered from the shading menu. Alright, before we start placing lights, let's first look at the render engine we're using. On the right side, open the Render Properties panel. You'll notice that Blender is currently set to the EEVEE render engine by default. EEVEE is extremely fast, which makes it ideal for real-time work like modeling, look development, and even animation previews. But it's important to understand one key difference. EEVEE is not physically accurate in the same way Cycles is. EEVEE is designed for speed. It relies on rasterization techniques, very similar to what modern game engines use to produce results quickly. It doesn't calculate real light paths. Instead of tracing true light bounces, it uses a series of approximations and screen-based techniques to simulate the result. Cycles, on the other hand, works very differently. Cycles simulates real light behavior by tracing rays of light as they bounce around the scene. Light can enter a material, scatter within it, refract, reflect, and exit again in a physically accurate way. That's why Cycles produces highly photorealistic images, especially when dealing with glossy surfaces and complex materials like our sugar glaze. And yes, Cycles is excellent for that level of realism. But the trade-off is time and performance. So instead of relying entirely on heavy physical calculations, we'll take a more practical approach. With well-placed area lights, thoughtful light direction, and screen space reflections, EEVEE can produce fast and beautiful results. For many materials and scenes, EEVEE is more than capable when it's set up properly. You'll quickly start to appreciate how important real-time feedback is while you're working. Imagine waiting hours, or sometimes overnight, for a single render, especially if you're working on a laptop. This, right here, is where many people become discouraged with 3D. But regardless of hardware, the goal is not to wait for the perfect GPU before creating. We work with the tools we have, and we make smart decisions to get the best possible results. Even though EEVEE won't produce a perfectly physical sugar glaze, I still want to show you how to work professionally inside EEVEE. This workflow is extremely valuable. After this tutorial, you won't be working only on donuts. You'll be building many different objects and scenes. If an object looks great in Eevee, then Eevee is absolutely the right tool for that job. And that's exactly why we're not skipping straight to Cycles. We build a strong foundation first. So for now, in the Render Properties panel, keep the render engine set to Eevee. Alright, now let's move into the sampling settings. This is where we start balancing image quality with viewport performance. Under Sampling, set the viewport samples to 64. This gives us a clean preview while keeping the viewport fast and responsive as we work. We don't want the scene to feel heavy or laggy while adjusting our lights. Right below that, enable jittered shadows. This helps break up harsh shadow patterns and produces smoother shadow transitions, especially noticeable on curved surfaces like our donut. Now set the render samples to 128. These samples are used for the final render. It produces a cleaner image with less noise while still keeping render times reasonable. So the viewport remains fast and the final result stays polished. Alright. Now scroll down to the ray tracing section and enable it. If fast GI approximation is enabled, disable it. For food materials, this option tends to flatten the lighting. It reduces contrast, softens the image too much, and removes the sense of depth we're trying to build. Here, we want crisp highlights, controlled shadows, and clear separation between light and dark, not uniform lighting across the surface. Next, expand screen tracing. Set the precision value to 0.75. This controls the accuracy of screen space reflections. Higher values increase the cost of performance, but for materials like glaze, the visual improvement is minimal, so this value gives us a good balance. Now set thickness to 0.2. This is important for thin surfaces. It helps reflections behave correctly on materials like sugar glaze, where the surface layer is thin but still reflective. Next, scroll back to the sampling section and make sure shadows are enabled. Set the shadow resolution to 1. This keeps shadows sharp enough without increasing memory usage too much. Then set rays to 4. This controls how many rays are used to calculate shadows. More rays produce cleaner shadows, and 4 gives us a nice balance between quality and performance. Now set steps to 16. This controls how smoothly shadows transition across surfaces. It helps avoid harsh edges and shadow banding, especially around delicate areas like the icing and the plate. Alright, one final adjustment. Scroll down to color management. Set the view transform to filmic. This gives us a wider dynamic range and a more natural light response. Then set look to medium-high contrast. This adds just enough contrast to help the highlights pop, without blowing out the sugar glaze or losing detail in the brighter areas. And with that, we now have a solid visual foundation in place, ready for building our lighting setup. Alright, now we're going to build a warm, early morning kitchen atmosphere. I want you to picture this for a moment. You wake up in the morning, walk into the kitchen, and soft sunlight is coming through the window. That's the mood we're going to create. Instead of using artificial lamps, we'll build a skylight setup that behaves like natural morning light. This approach works very well in Blender Eevee, and it avoids fighting against the engine. First things first, delete any lights currently in the scene. We want full control, starting from a clean setup. Now go to the World Properties panel. Next to Color, click the yellow color dot and choose Sky Texture. As soon as you do that, the scene will light up immediately. This sky texture provides two important lighting components at the same time. First, ambient skylight, the soft, diffuse light coming from the entire sky dome. Second, a directional sunlight component, including a visible sun disk. Now here's an important detail to understand. In Eevee, the sky texture mainly contributes ambient lighting. The engine does not treat the sun disk as a true directional light source, so Eevee won't automatically produce strong sunlight or define shadows from the sky texture alone. That's why, in Eevee workflows, We typically add a sun lamp manually to generate proper directional sunlight. In Blender Cycles, the situation is different. Cycles fully supports both the ambient sky lighting and the sun disk directly from the sky texture. So just keep that difference in mind as we move forward. Now rotate your viewport slightly and notice how the skylight reacts across the scene. By default, the sky brightness is extremely strong, much brighter than what we need, so we'll bring it under control. Go to the Render Properties panel, scroll down to Color Management, and find the exposure value. Hold Ctrl while adjusting the slider to snap more precisely, and reduce the exposure to -2, or simply type the value directly. This pulls the brightness into a manageable range while preserving contrast. Now return to the sky texture settings in the World Properties panel. The elevation controls the time of day. When the elevation is low, the lighting feels like early morning or late evening. When the elevation is high, it starts to resemble midday lighting with the sun overhead. Set the elevation to about 15 degrees. This gives us a convincing morning sun angle. Next, rotate the sun rotation to 90 degrees. This allows the sunlight to enter from the side rather than directly from above. Side lighting is far more cinematic, and it works much better for interior scenes like this. Now increase the sun disk size to around 2.5. Even though Eevee doesn't render the visible sun disk itself, this value still influences the environment lighting. Increasing the sun disk size slightly broadens the bright region in the sky texture. That softens shadow transitions and improves how light behaves on glossy surfaces. This becomes especially helpful for materials like the donut glaze. And this setup will also translate nicely if we render later in Cycles, so we won't need to rebuild the lighting from scratch. Next, increase the dust value to 2. This adds a subtle atmospheric warmth to the light and keeps the environment from feeling overly sterile. Finally, adjust the world strength to around 0.5. This keeps the environment lighting clean and controlled, almost like a studio skylight, without flattening the contrast. Alright, now we have a nice skylight setup, but notice something important. The light is currently coming from every direction. In the real world, light is always shaped by its surroundings: walls, ceilings, windows, and objects in the room. If we want realistic lighting behavior, we need to give the light something to interact with. So we're going to build a simple room enclosure. Press Shift-A, go to Mesh, and add a cube. Scale the cube up until it forms the walls of a room around your countertop. Don't worry about perfect alignment yet. We'll adjust that in a moment. To make this easier, switch to wireframe view. Wireframe makes it much easier to see through the geometry and align things cleanly. Now press G, then hold B to activate snapping. As you move your cursor around, notice how the snapping icon changes. A circle snaps to faces, a crosshair snaps to edges, a triangle snaps to edge centers, and a square snaps to vertices. What we want here is vertex snapping. Select one corner of the cube, move it, and snap it directly to a vertex on the countertop. Single click, and it locks perfectly into place. Now repeat this process for the top corners. Press G, then B, and snap each point carefully. Take your time here. Clean alignment helps a lot later on. Make sure the cube lines up properly with the backsplash and countertop. As you move around the cube, you might notice some flickering. That happens because the cube still has all 6 faces, and some of them overlap with the countertop and backsplash geometry. To fix that, enter Edit mode. Switch back to Solid View. Then choose Face Select mode. Select the back face, then Shift-select the bottom face. Press X and delete them. Next, we'll create a window opening. This is where the light will enter the room. Select the left wall face, switch to wireframe view again. Press I to inset the face. Scale the inset inward until it starts to resemble a window frame. Hold Shift while scaling if you want finer control. Once the shape looks right, Press X and delete that face. This opening now acts as a light entry point. Instead of light spilling evenly across the entire scene, it now enters the room from a defined direction. Switch back to solid view. Enter edit mode. Select the back face of the cube. Press G, then Y, and move that face outward slightly. Not too far, just enough space so the camera can sit inside the room and move comfortably without intersecting the wall. Yes, right there. That's perfect. Now let's position the camera. Switch back to object mode and select the camera. Think of this exactly like placing a real camera inside a studio setup. Press G, then Y, and move it slightly to the left. Now rotate it. Press R, then Z, and slowly turn it until it faces toward the donuts. Yes, that angle works well. Press G, then X, and slide it toward the center. Then press G, then Z, and raise it slightly. With the camera selected, go to View, Navigation, Fly Navigation. Fly mode works a bit like a video game camera. W moves forward. S moves backward, A moves left, D moves right, E moves up, Q moves down. This allows you to move around the scene quickly and find a good composition without constantly rotating the camera manually. Fly around the scene for a moment. Look for a dramatic angle that shows off the donut nicely. Don't worry about perfection. We can refine the framing later. Left-click to confirm or press Escape to cancel. Alright, that's good for now. Next, we'll add directional sunlight. Even though we already have skylight, we still need a strong directional source to create highlights and shadows. So we'll add a sun lamp and place it outside the window. This will become our main light source. Press Shift right-click to move the 3D cursor to the side of the scene. Then press Shift A, go to Light, and add a sunlight. Now we need to align this light with the sun direction we set earlier in the sky texture. Rotate the sun lamp along the Y-axis. We want a morning sunlight angle, coming through the window from the side and casting downward across the donuts. Switch back to rendered view so we can see the lighting clearly. Think about how real sunlight behaves. It rarely falls straight down. Instead, it enters through the window, touches the wall, stretches across surfaces, and gradually fades into shadow. Move the sun lamp near the window. Technically, the position of a sun lamp doesn't affect the lighting, only its rotation does. But placing it near the window makes the direction easier to visualize. Try to imagine the light rays entering through the window, brushing against the wall, and falling on the donuts. Now enable shadows on the sun lamp. This is essential for producing clean, directional shadows. You should now see sunlight clearly entering the room through the window. At the moment, though, the sunlight is still a bit weak. It doesn't illuminate the space the way real morning sunlight would. So let's adjust that. Increase the strength to around 2.5. You'll notice the light spreading further into the room. Next, enable temperature. Morning sunlight typically falls somewhere between 3000 Kelvin and 4000 Kelvin. Let's try 4000 Kelvin first. Take a look. The light becomes warmer, but still slightly bright, almost leaning toward neutral daylight. Now reduce it to 3500 Kelvin. Yes, that feels better. The light becomes softer and slightly golden, like the sun has just risen high enough to shine through the window. This warmth is important because materials like chocolate and sugar respond beautifully to warm light. Now adjust the exposure of the sun lamp. Try 0.6. Observe the overall balance. It looks good, but slightly restrained. Increase it to 0.8. There. Now the illuminated area feels balanced, like real morning sunlight filling a small kitchen space. Next, adjust the sun angle. Set it to 2 degrees. Watch the shadow transition. See how the shadow edge becomes softer. That subtle diffusion is exactly how early morning sunlight behaves. Midday sunlight would be sharper and more direct. At this point, we have a convincing morning lighting setup. Soft shadows, warm temperature, directional light entering through the window, brushing across the wall, sliding along the countertop, and resting on the donuts. Now let's adjust the window frame slightly. Enter Edit Mode and switch to Edge Select. You may notice that the backsplash area looks slightly darker. That's because part of the frame is blocking light from reaching that surface. Even a small obstruction can steal a surprising amount of light. So move the window frame outward just a little. Not too much, just enough to allow the light to reach that surface. Then push the lower edge down slightly. That's perfect. Now select the camera again. Press Ctrl-tilde to enter fly navigation. Move slowly and look for a position where the light pattern is clearly visible. Right there. That's a strong composition. Alright, at this stage the skylight is working well, but the lighting is still slightly uncontrolled. If you look carefully, the back wall is bouncing too much light back into the scene. This reduces contrast and flattens the image. In photography, artists often solve this using a black fill card. A black card absorbs light instead of reflecting it, which helps shape shadows and increase contrast. We're going to simulate that same idea here. First, select the room cube and go to the Materials tab. Create a new material and name it white. This will be the default material for the walls. Now click the plus icon to add another material slot. Create a second material and name it black. Change the shader from Principled BSDF to Diffuse BSDF. Set the color to a very dark gray, almost black, but not pure black. This type of surface absorbs light rather than reflecting it, which is exactly what we want. Now enter Edit Mode. Switch to Face Select mode and select the wall that's causing the excessive light bounce. Choose the black material and click Assign. Notice what happens. That bright reflective wall suddenly stops bouncing light back into the scene and instead begins absorbing it. You should immediately see stronger contrast. Shadows become more defined and the unwanted light bounce disappears. One more thing. Before we lock in the final lighting setup, there's something important I want to mention. In real production work, when we build larger 3D scenes, we almost never model every object ourselves. Instead, we rely heavily on external 3D assets created by other artists. And this is a very normal part of the workflow. Using external models saves an enormous amount of time. It allows us to avoid rebuilding every single object from scratch inside Blender. For a small project, like this donut scene, modeling everything can feel manageable, even enjoyable. But once a scene grows larger, with tables, props, background objects, and full environments, the workload increases very quickly. So learning how to import and manage external 3D assets is a key professional skill. Let me show you how that works in practice. Open your browser and go to Google. Search for Sketchfab. You can also find the link in the video description. Sketchfab is one of the most popular platforms for 3D content online. Artists from all over the world upload and share their models there, and many of them are available for free download. Once you're logged in, you'll have access to a large library of both free and paid 3D models. You can download models for your own projects, and you can also upload and share your work with the community. Now let's use this to add a coffee mug to our scene. In the search bar, type coffee mug. Take a moment to browse the results and find a realistic mug that fits the style of our donut scene. Once you find one you like, click Download. After the download finishes, unzip the file. Inside the extracted folder, you'll usually see a model file and a textures folder. Open the textures folder and move all the texture files into the same folder as the model file. This helps Blender locate the textures correctly when the model is imported. Now go back to Blender. At the top menu, click File. Then choose Import and select the file format you're importing. In this case, it's an FBX file. Navigate to the folder where you extracted the files. Select the FBX file and click Import FBX. Blender will immediately bring the model into your scene. When it appears, scale it up until it feels proportional to the rest of the scene. Then move it slightly to the side. Raise it slowly until it rests on the countertop. I may scale it up a little more. Then rotate it along the Z axis until the orientation looks right. Yes, that works. And just like that, we've added a realistic coffee mug to the scene in only a few seconds. This is exactly how professional workflows handle larger environments. Reusable assets save time, improve overall scene quality, and allow us to focus on the most important parts of the work, lighting, composition, and storytelling, rather than rebuilding every object. Now that the coffee mug is in the scene, we can manipulate it just like any other object created directly in Blender. Translation, rotation, scaling, everything works the same way. Once you get used to importing external assets, it feels completely seamless. Now let me show you a common issue that often appears with imported models and how to fix it. First, go to the Viewport Overlays menu and enable Statistics. This displays real-time information about your scene. Notice the triangle count. This number tells you how many polygons exist in the scene, which directly affects viewport performance and rendering speed. The higher the triangle count, the denser the mesh becomes. More polygons usually mean slower viewport interaction, longer render times, and larger file sizes. Here's the important part to understand. External models are extremely useful for building large scenes, like game environments, cinematic sets, or detailed interiors, because modeling everything manually would take far too long. But in most situations, we prefer models with lower polygon counts. Game engines and real-time renderers especially rely on low poly models to maintain smooth performance. The problem is that imported assets sometimes arrive with extremely high polygon counts. They may include unnecessary subdivisions, overly dense topology, or details that simply aren't needed for the shot. This can slow down the entire scene. So how do we fix that? We reduce the polygon count while keeping the overall shape intact. In Blender, one of the most useful tools for this is the Decimate modifier. Here's how we use it. Select the coffee mug, then Shift-select the saucer. Go to the Modifier tab. Click Add Modifier, then under Generate, choose Decimate. Set the type to Collapse and change the ratio to 0.4. What this does is merge vertices and simplify the mesh topology. The modifier preserves the overall shape of the model while removing unnecessary geometry. Look at the triangle count before and after applying the modifier. You'll notice a significant reduction, but visually, the model still looks almost identical. This is a very common technique used by game artists and production teams. The goal is simple. Keep the same visual result, but with smaller file size, better performance, and a cleaner scene. And that becomes especially helpful later when we start working with animation, lighting, or final rendering. Everything runs smoother. Now, very quickly, let's place our scene objects into their final positions. I'll start by selecting the plate, then hold Shift and select both donuts. Now rotate them along the Z axis, just like that. I'm looking for a pleasing composition. Let me orbit around the scene for a moment and observe the objects from different angles. Sometimes something looks good from one angle, but awkward from another, so it's always worth checking. I might move this donut slightly to the right, and this one as well, just enough so the placement feels intentional, like someone placed them there. I may also scale the plate down slightly, just a little. Yes, that feels better. Now let's go back to the camera view and see what the viewer will actually see. Maybe the donuts themselves should be slightly smaller. I'll select the donuts and the plate together and scale them down slowly, watching how they relate to the camera frame and the surrounding space. They should feel believable within the room. For clarity while adjusting, I'm also going to hide the sprinkles in the viewport. So I'll select the sprinkle objects, go to the outliner, and disable the viewport icon for the sprinkles collection. Now the scene looks much cleaner. Next, I'll move the coffee mug a little closer to the donuts. It shouldn't sit too far away if it belongs in the same moment of the scene. Yes, that works. Take your time adjusting the objects until the arrangement feels intentional. There's no strict formula here. You move things, observe, and trust your eye. I may shift the camera slightly toward the center. We don't want the back corner edges of the room distracting the viewer. So I'll also move the objects slightly toward the center, just enough so the camera frame contains everything. Nothing gets cut off. You might not have much to adjust if your scene already looks clean. In my case, I'm refining the camera position and angle, making sure the framing feels deliberate. Alright, let's switch back to rendered view. Now I might adjust the window frame slightly, just to fine-tune how the light enters the room. Small changes here can dramatically affect the lighting pattern. The glaze drips on the donut look a little repetitive, and repetition like that can feel artificial. So let's break that symmetry. I'll rotate the glazed donut along the Z-axis, slowly searching for a side where the drips look more random. There, that side feels much more natural. Perfect. We've made a lot of subtle adjustments, and now the scene feels balanced and interesting. Everything has a purpose. Everything feels intentional. And most importantly, it doesn't feel artificial anymore. Yeah, we're there. Now let's add a very soft fill light. This light is not meant to be noticeable. Its purpose is simply to control contrast and gently lift a few of the darker areas. We're not lighting the scene again here. We're balancing the lighting that already exists. If the room walls are blocking your view while placing the light, switch to wireframe mode so you can see through the geometry more easily. Now move the 3D cursor to the front center area of the scene using Shift right-click. Press Shift-A, go to Light, and add an area light. With the area light selected, rotate it along the X-axis. Set the rotation to -90 degrees. This aligns the light nicely with the scene, positioned opposite the direction of the sunlight. Now scale the light up. Make it quite large, roughly the size of the scene itself. A larger light source produces softer reflections and smoother highlights, very similar to the effect of a large softbox in studio photography. Press G, then Z, and move the light upward slowly until it sits above the Z-plane. Yes, right there. Next, rotate the light slightly along the X-axis. Set the rotation to about 45 degrees so the light gently points toward the donut, just like that. Now bring it closer to the donut, not touching the objects, but close enough to influence the surface. This light will create very soft highlights, similar to what you see in professional food photography. It shouldn't compete with the skylight, and it shouldn't overpower the sunlight. Its job is simply to support the existing lighting. Now, before adjusting the settings, let's temporarily disable the sunlight in the viewport. When multiple lights are active at the same time, their effects overlap. That makes it difficult to clearly see what each light is contributing. In studio lighting, and also in 3D, artists usually work with one light at a time. They isolate the light, study its effect, and then refine it carefully. So for now, we'll focus only on this area light. Our goal is simple. We want it to enhance contrast while gently lifting the darkest areas, especially where the shadows feel a little too heavy. Start by increasing the strength. Begin with 50 watts. Next, slightly increase the exposure. Let's set it to 1. You should already notice a change. The shadows begin to open up a bit. Now push it just a little further. Set to 1.2. Yes, that feels better. Next, enable temperature. For this fill light, we want a slightly neutral tone, similar to clean midday light. That will balance nicely with the warmer sunlight we created earlier. Good, that's enough. Now take a moment to observe the effect. This light gently fills the darker areas where shadows were too heavy. It softens the contrast and introduces subtle highlights across the surface. It behaves very much like a large studio softbox, but let's push it just a little further. Increase the strength slightly to 60 watts. This is before, and this is after. Notice how the shadows soften and the lighting feels more controlled. Now re-enable the sunlight and look at the combined result. Focus on the donut and the plate. Without the fill light, the shadows become too strong. They collapse into deep darkness around the plate's rim and inside the donut hole. The shadows from the coffee mug feel a little too heavy. Even the highlight on the donut becomes weaker. But once the area light is active again, the difference becomes clear. The shadows soften, the highlights become smoother, and the overall lighting feels more natural. That was the goal from the beginning, to soften, to enhance, and to balance the scene. Now we have a complete lighting setup. The skylight, the directional sunlight, the black fill wall, and this controlled fill light. Together, they preserve the bright sky color, keep the shadows soft, and maintain those warm highlights across the donut. Great work, everyone. In the next section, we'll move into animation. I'll see you there. Welcome back. Let's bring our scene to life. Now it's time to move into animation. More specifically, we'll start working with keyframe animation, the core principle behind how animation works inside Blender. Keyframes are simply a way to tell Blender, at this exact moment in time, this object should be here. Then later, at another moment, it should move there. From those few instructions, Blender automatically calculates everything that happens in between. So instead of animating every single frame by hand, we only define the important moments, and Blender handles the motion that connects them. In this section, our goal is to create a cinematic camera movement, something intentional that really shows off our donuts in a clean, appealing, professional way. Here's the idea. We'll start with the camera positioned slightly above the donuts, entering from the left side of the scene. Then, very gradually, the camera moves downward and across to the right, almost like it's spiraling around the subject, before settling into a satisfying final reveal of the finished plated donuts. If you picture the motion, it's not a straight movement. Instead, the camera slowly wraps around the subject, letting the viewer discover the donuts rather than revealing everything all at once. This kind of camera animation is widely used in professional product cinematography. You'll see it all the time in food commercials, product advertisements, and cinematic product showcases. The motion gives the viewer time to appreciate the details. Alright, let's begin. First, switch to solid view. Then move your cursor down to the bottom of the screen. Click and drag the divider upward so we can reveal the timeline. If you scrub the timeline right now, you'll notice that nothing moves yet. That's completely normal. At this stage, we haven't told Blender to animate anything, so there's nothing to play. Before we animate the camera, it's important to make sure the camera itself is configured properly. Go ahead and select the camera. Then, in the Properties panel, switch to the camera settings. That's the green camera icon. The setting we want to check is the focal length. For a donut showcase like this, a focal length between 50 and 80 millimeters usually works very well. This range avoids wide-angle distortion where objects start stretching or bending. Instead, it produces a perspective that much closer to how we naturally see objects in real life. Alright, technically, we could animate the camera using simple location keyframes. You move the camera here, insert a keyframe. Move it there, insert another keyframe, and yes, that method works. But most of the time, that approach ends up looking a little mechanical. The camera ends up sliding through space instead of moving with intention. So instead, we'll use a much better and more cinematic technique, a pivot-based camera setup. This method allows the camera to move in smooth, controlled arcs while always staying focused on the subject. It's the same technique used in many professional product shots, especially in food cinematography and commercial work. Before setting this up, we need to decide one important thing. Where should the camera stay focused during the motion? In our case, that's very clear. The donuts are the hero of the shot, so our pivot point, the center of the camera movement, should sit roughly in the middle of the donuts. Hold Shift and right-click directly in the center of the donuts to place the 3D cursor there. Take a moment with this step. Precise placement really matters. Because everything will rotate around this point, now press Shift-A, add an empty, and choose the sphere type. Scale it down a bit. Just to clarify, this object won't appear in the final render. An empty is simply a helper object. It's visible in the viewport so we can work with it, but it never shows up in the final image. Think of it as an invisible control handle that we'll use to guide the camera. Next, we need to connect the camera to this empty. First, select the camera, then Shift-select the empty. Press Ctrl-P and choose Object, Keep Transform. This is the same parenting method we used earlier when attaching the icing to the donut. What this does is simple but extremely powerful. The camera keeps its current position, nothing jumps or snaps, but now its movement is controlled by the empty. Try rotating the empty for a moment. You'll see the camera smoothly orbit around the donuts while always staying focused on them. That's exactly the behavior we want. And this is why pivot-based animation works so well. Instead of the camera drifting randomly through 3D space, the motion becomes intentional, controlled, and much more cinematic. Alright, now we're ready to animate. The camera angle you're seeing right now will be our final hero shot. This is the moment where the donuts look their absolute best. So this position will become the end of our animation. You can choose any animation length you like, but for this scene, we'll use 120 frames. That gives the motion enough time to properly showcase the donuts. Before we begin, make sure the empty is selected, not the camera. That's important. All of our animation will happen through the empty, since it's driving the camera motion. Now move the playhead to frame 120. You can drag the playhead along the timeline, or simply type the frame number. Press N to open the Properties panel, then go to the Item tab. Here, we'll focus on the rotation values. Hover your cursor over the rotation fields, right-click, and choose Insert Keyframes. This records our final camera position, So now Blender knows, at frame 120, this is exactly how the camera should be. That's our ending keyframe. Next, move back to the first frame. You can drag the playhead all the way back or press Shift left arrow to jump directly to frame 1. At frame 1, we're going to define the starting camera angle. Rotate the empty along the X-axis so the camera starts higher and looks downward toward the donuts. That works nicely. Now rotate along the Z-axis. Turn it slowly while watching the edges of the frame. Make sure the camera doesn't clip through any objects. Before changing frames, we need to capture this starting position. Once again, right-click on the rotation values and choose Insert Keyframe. Now Blender knows exactly where the camera starts and where it ends. Press space to play the animation. You'll see the camera rotate smoothly from the upper left down toward the lower right, orbiting around the donuts. Technically, the animation works, but the motion still feels a bit linear, almost mechanical. This is where refinement really matters. In cinematic animation, camera movement rarely happens at a constant speed. Most of the time, the motion begins a little quicker and then gradually slows down as it approaches the final shot. That subtle slowdown, known as easing, it makes a huge difference in professional animation. To get better control over that motion, switch to the animation workspace at the top. This replaces the regular timeline with the dope sheet, giving us more precise control over how the animation behaves over time. Take a look at the rotation channels. For this animation, we only need rotation on the X and Z axes. The Y rotation isn't doing anything useful here, so select the Y rotation channel and delete it. Keeping only the channels we actually need helps keep the animation cleaner and much easier to manage while we refine the motion. Alright, now we're getting into the really fun part, polishing the motion. In the top left corner, change the editor type to the graph editor. Use the middle mouse button to pan around the graph, and press home to frame all the curves so you can see the entire animation range. Start by selecting the X rotation curve. The graph editor is where the real animation control happens. It shows exactly how the animation values change over time, and this is where smooth cinematic motion is created. Right now, you'll probably notice something familiar. The motion starts slowly, speeds up through the middle, and then stops a little too abruptly at the end. We're going to refine that by reshaping the curve. Select the Start Keyframe handle. Press R to rotate it, and then slightly pull the handle inward, like that. This gives the beginning of the animation a little more momentum. Now move to the final keyframe. Press S, and scale the handle outward slightly. That creates a smoother slowdown as the animation reaches the final shot, the easing we talked about earlier. Instead of the camera stopping suddenly, it gradually settles into the final reveal. Now select the Z rotation channel. Just like before, rotate the start handle slightly, then move to the final keyframe and scale its handle outward. Good. Now press space and play the animation. You'll notice the difference immediately. The camera starts a bit quicker, sweeps smoothly around the donuts, and then eases into the final hero shot. That's exactly the motion we're aiming for. Now, let's take the shot one step further. We can add another layer of movement by animating the camera distance using the scale of the pivot object. This technique is really useful. It allows the camera to start closer to the donuts and then slowly pull back as the animation progresses. That subtle pullback adds depth and gives the shot a stronger sense of three-dimensional space, almost like the camera is gliding through the scene. Move the playhead to the final keyframe. Hover over the scale values, right-click, and choose Insert Keyframes. Then move back to the first frame. Scale the empty slightly smaller so the camera starts a bit closer to the donuts. That looks good. Now right-click on the scale values again and insert another keyframe. If you look in the graph editor, you'll now see a new curve representing the scale animation. For a moment, hide the rotation curve so we can focus only on the scale. Just like we did earlier, select the final keyframe handles and scale them outward slightly. This creates a smooth pullback motion that complements the rotation we already animated. Select the Y scale channel. Scale its handles outward the same way. Good. Finally, repeat the same adjustment for the Z channel. Scale the handle outward in the same way so the motion stays consistent. Nice. Combined with the rotation we created earlier, the camera is now performing a controlled cinematic movement instead of a simple rotation. And that's exactly the kind of motion we want for a professional donut showcase. Take a moment to watch the animation play. Everything flows smoothly, arcs around the subject, and eases perfectly into the final shot. Just like we planned. While the animation is playing, look at the top left corner of the screen. You'll see FPS, which stands for frames per second. By default, Blender uses 24 frames per second, which is the traditional cinematic frame rate. For something slightly smoother and a bit more modern, we can increase this to 30 frames per second. Open the output settings. Find the frame rate drop-down under Format and set it to 30. You might also notice the animation continues past frame 120. That's because the end frame is still set to 250 by default. Simply change the end frame to 120. Now when you play the timeline, the animation runs exactly from start to finish. And that completes our animation phase. Smooth, controlled, and cinematic. Next, we'll move into cycles rendering. So go ahead and join me in the next part. Welcome back. We've pushed a long way to get here. A lot of small decisions, careful adjustments, and honestly, a lot of patience. Step by step, we've put in the hard work. And now we're moving into the final stage of this tutorial. This is the moment where everything starts to come together. All of those earlier choices begin to pay off. This is where the glaze finally comes alive, where the material begins to feel real, not just visually, but physically, where Cycles gives us accurate light behavior, believable reflections, and shadows that actually sit inside the scene instead of floating on top of it, and where composition helps guide the viewer toward the final image we want to present. So here's the plan. First, we'll push the donut and glaze materials into the Cycles rendering engine, letting realism take priority over render speed. Then, we'll do some compositing, not to change the image, but to enhance what's already there. And finally, we'll render the scene and generate the final animation. All right, let's begin. For rendering, we'll switch to the Cycles render engine. Cycles is designed for physical realism. It calculates light the way it behaves in the real world. That level of accuracy comes with longer render times, but for a project like this, it's absolutely worth it. When Cycles first starts rendering, the image usually looks rough. You'll see a lot of noise, small grains scattered across the frame. As more samples are calculated, the image gradually cleans itself up, detail by detail, until it settles into a smooth result. Now inside Blender, you'll notice two sampling settings, viewport samples and render samples. They look very similar, but only the render samples affect the final animation you export. Viewport samples exist purely to keep the scene responsive while you work. So for the viewport, set the samples to 32. This keeps the preview light and responsive. For the final render, set the maximum samples to 300. This gives us a solid balance, clean enough to look polished without pushing render times too far. If you have more time or a stronger system, you can absolutely go higher. Rendering at higher sample counts, even up to 1,000, can produce a more refined image. But for this tutorial and for most practical cases, 32 viewport samples and 300 render samples is a very reasonable setup. Blender also includes a denoising feature to help reduce remaining noise. Go ahead and enable denoising for both the viewport and the final render. Think of it as a final cleanup pass. It doesn't replace proper sampling, but it helps smooth out the last bits of noise and bring the image together nicely. Before we move on, take a careful look at the scene. You might notice something subtle. Right now, two different shadows are being created. One shadow comes from our main cycle's sunlight, the strong, directional shadow. And the other one comes from the sunlight we added earlier for Eevee, the softer, lighter shadow. When both lights remain active, they quietly compete with each other, and the result isn't physically accurate. If you look closely at the sugar glaze, you'll also notice the surface appears a little too bright. That extra brightness and the second shadow are both coming from that earlier sunlight. So for now, let's disable it. Select the sunlight in the outliner, then disable the viewport icon and also the camera icon. There we go. Now the scene is driven by a single directional light. One shadow. Clean and physically consistent. Alright, next, let's adjust the window frame slightly to allow a little more light to enter the room. Select the cube, enter edit mode, press G, then Z, and slowly pull it downward. Just a small adjustment, enough to allow the light rays to stretch a little further into the room. That's enough. Switch back to object mode. Take a look. Nice. The light feels much better now. Now let's finish building the sugar glaze material. This is the perfect moment to do it. Earlier in the tutorial, we were working mostly with visual approximations, but now, under Cycles, we finally have physically accurate lighting, so the material can start behaving the way it does in the real world. For the sugar glaze, we'll introduce transmission, and for the donut base, we'll add a small amount of subsurface scattering, just enough to let light do what it naturally wants to do. So first, select the glaze, open the shader editor, and switch to rendered view. Here's the idea behind transmission. Sugar glaze isn't fully transparent, but it's also not completely opaque. Light can pass through it slightly, especially in thinner areas. And that subtle light travel is a big part of why real glaze feels glossy and moist instead of flat. Transmission allows us to simulate that behavior. Set the transmission weight to about 0.4, not too high. We don't want the glaze to look like glass, just enough to allow light to slip through in the right areas. Now, to make this feel natural, we need variation. Real glaze is never evenly thick. Some areas stretch thin as the glaze drips downward. Other areas pool and build up. That variation in thickness directly affects how light passes through the material. So let's duplicate the noise texture and color ramp we're already using for roughness. Then feed that setup into transmission. This noise is not about surface texture. It's not about bumps or micro detail. It's about thickness variation. Now adjust the noise texture. Set the scale to 6. Set the detail to 2. Then move to the color ramp. Set the black position to about 0.18. Set the white position to 0.64. Then change the interpolation from linear to ease. That softer transition is important. What this gives us is natural variation. Some areas allow more light to pass through, while other areas block it slightly. That's exactly how real glaze behaves. But if you look very carefully, you might notice something missing. Light isn't quite traveling through the glaze the way we expect. Ideally, light should enter the glaze, scatter slightly within the thin sugary layer, and exit again, producing that smooth, glossy shine. Right now, that internal light movement feels a bit restricted, and the reason comes from the displace modifier we added earlier. That modifier is altering the geometry. It pushes certain vertices inward and pulls others outward, creating uneven depth across the glazed surface. While that worked well for surface breakup earlier, it also interrupts how light travels through the material. Instead of moving smoothly through a thin layer, the light keeps changing direction because of those geometric distortions. That weakens the soft, translucent glow we're trying to achieve. For sugar glaze, we want a cleaner light path. Light should enter the glaze, move freely within the thin layer, and scatter naturally. So try temporarily disabling the displace modifier in the viewport. Watch what happens. Immediately, the glaze becomes cleaner and more transparent. The light is finally free to move through the material without interruption. And now, the transmission begins behaving exactly the way we intended. Light passes beautifully through the thinner areas of the glaze, creating that glossy, translucent shine you see in fresh sugar glaze. Where the glaze becomes thicker, the light is slightly blocked. The surface appears a bit milky, similar to how real sugar crystallizes when glaze builds up. That variation is what gives the material its realism. And honestly, it's what makes the donut look delicious. From the very beginning of this tutorial, this was our goal. And now, we've reached it. So at this point, we can remove the displace modifier from the sugar glaze. However, we'll keep it for the chocolate glaze. Chocolate glaze is thicker, less translucent, and more textured, so that surface variation still works well there. Now a quick but important note. In the real world, light does not pass through chocolate glaze. Chocolate is dense and heavily pigmented. Light interacts with it mostly through reflection, not transmission. So for the chocolate glaze, we don't add transmission at all. Next, select the donut base. Here we'll introduce subsurface scattering. Subsurface scattering simulates light entering a solid surface, bouncing around inside the material, and exiting at slightly different points. It's perfect for materials like dough, soft, porous, and organic. Set the subsurface weight to 1. Now watch the surface carefully. Notice how the light begins to enter the dough, especially around the edges. See how it softly brightens those areas. That's subsurface scattering. Now set the radius evenly on all axes. Set each value to 1. This tells Blender that light should scatter equally in every direction beneath the surface. Next, reduce the scale. Bring it down to a very small value, around 0.02. As you lower the scale, you'll see the effect become tighter and more controlled. This effect should stay very subtle, almost invisible at first glance. It simply gives the donut that soft, baked dough quality. One more note about material behavior. We don't add subsurface scattering to the glaze. Sugar glaze allows light to pass through it, not within it, so transmission handles that behavior much better. And the sprinkles are dyed sugar crystals. They're dense and opaque, so again, no subsurface scattering there either. Each material in the scene is now behaving exactly the way it should physically behave. Now take a moment and look at what we have. This is now behaving like a real glazed donut. What we've built here is a physically believable sugar glaze, a clean shader structure, and a surface where thickness varies naturally, just like real poured glaze. At this stage, the material itself and the way light interacts with it is no longer limiting our realism. But realism never comes from the material alone. As I mentioned earlier, lighting still plays a huge role in the final result. In real food photography, artists rarely rely on a single light source. They carefully combine multiple lights, because one strong light, by itself, rarely produces the depth and highlight behavior we expect, especially for glossy materials like sugar glaze. Beyond the shader, lighting strongly determines how believable the glaze appears. This isn't about color, it's about how real light behaves. Every highlight, every reflection, every refraction, every soft shadow. Those elements define glossy materials far more than color ever could. That's exactly why the shader looked a little artificial earlier inside Eevee. For someone new to 3D, that can even feel confusing. You might look at the material and think, is this really sugar glaze or something fake? But this layered process is exactly how real artists work. And remember, my goal in this tutorial was to teach a production-style workflow, not just how to build a donut. Sugar glaze simply happens to be the perfect example for demonstrating that process. So now, let's refine the lighting once again. Earlier, we added an area light and a sunlight for Eevee. Now that we're working in cycles, we'll keep both of those lights exactly as they are. Open the outliner, enable both the viewport and render icons for the sunlight, and if the area light is disabled, enable it as well. Now don't follow along just yet, simply observe. I want to show you the difference during rendering. If I go to Render, then Render Image, this is the result we get. Now I return to Layout, select the sunlight, and disable its shadow. Then once again, Render, Render Image. This is the second result, with the sun shadow turned off. Now one more comparison. If I completely disable the sunlight from rendering, it will no longer influence the scene at all. Now render again. Here we can compare how each lighting configuration affects the scene, side by side, in real time. Take a careful look. When both shadows are active, the image feels less realistic because two separate shadows are being created. Even though we want combined lighting, we don't want competing shadows. Instead, we want one clear shadow from the main light and only soft highlight contribution from the secondary light. So for this setup, we disable shadow on the sunlight. Now compare image 2 and image 3. Image 2 looks cleaner and easier to read. We get that strong specular reflection and a smooth highlight across the sugar glaze. The chocolate glaze also appears creamier, which is exactly what we want. But in image 3, we lose a lot of that surface detail. Chocolate absorbs more light energy than sugar glaze. It's naturally darker. So when the lighting becomes slightly weaker, the light simply sinks into the surface. It doesn't bounce back strongly. And when that happens, the material stays dark instead of looking rich and creamy. So our main sunlight alone is not quite strong enough. It can't fully protect the chocolate surface from falling into shadow. It benefits from that second light source, which helps preserve those soft highlights. And for the sugar glaze, that additional light also helps maintain clean reflections. So for now, we'll keep the configuration from image 2. At this stage, what I want you to understand is how multiple lights work together in a scene. Observe what each light contributes and how small changes affect the final render. However, this still isn't our final lighting setup. It works beautifully for the sugar glaze and chocolate glaze, but it doesn't work as well for the marble, the coffee mug, or the plate. And that's completely okay, because right now we were focused on achieving realistic glaze materials, nothing else. Later, when we refine the entire scene, we'll improve the lighting further. Just like we refined the materials, we'll do the same with the lighting. We'll keep pushing it forward until the scene reaches a strong and believable balance. So far, our process has been very intentional. We started simple. We introduced different light types. We explored their direction and their position. Now we're combining 3 lights, and we clearly understand what each one contributes. Next, we start thinking more like artists. We'll begin using lighting diagnostic tools to analyze the scene, studying exposure, and making decisions based on observation. All right, now let's move on to compositing. Before we jump in, it's worth taking a moment to understand what compositing actually is and why we're using it here. Compositing happens after the render is complete. At this point, the materials have already done their job. Now we're working directly with the final image. You can think of it like photo editing for a 3D render. This is where we adjust contrast, manage highlights, and add subtle effects that make the image feel more photographic. In our case, we'll use compositing to enhance the highlights on the glaze. Glossy surfaces interact strongly with light, and in real cameras, those highlights rarely stay perfectly sharp. They usually bloom slightly. They spread softly across the surface. That subtle glow is what we're trying to recreate. For contrast, we've already benefited from Blender's built-in color management. It does a great job handling dynamic range automatically, so we won't be doing any heavy color grading here. Blender has already given us a strong foundation. To get started, switch to the Compositing workspace. Enable Use Nodes. Then enable Backdrop, so the rendered image appears behind the node editor. At first, nothing will appear, and that's completely expected. We haven't rendered an image yet. Compositing only works after a render exists. Remember, compositing is post-processing. It operates on the rendered image, not the scene itself. So now go to Render, Render Image. Once the render completes, return to the Compositing workspace. You should now see render layers connected directly to Composite. If the image still doesn't appear in the backdrop, simply toggle backdrop off once and then enable it again. Now the image should display correctly. This is our starting point. And there's one important thing to remember here. The composite node is what actually gets saved to disk. It represents the final image output. The viewer node, on the other hand, is only for preview. It allows you to inspect the image inside the node editor, nothing more. So if nothing is connected to the composite node, none of your compositing effects will appear in the final render. Everything might look correct in the node editor, but when you export the image, those effects will be missing. So always make sure your final node chain flows into composite. All right, press Shift-A. Go to Filter and add a glare node. Place the glare node right after render layers. Change the glare type to Fog Glow. Fog Glow is one of the most natural options for food and product renders. It mimics how real camera lenses soften and spread intense highlights instead of creating sharp star shapes or streaks. Now, let's dial in the settings carefully. Set threshold to around 0.85. This is important. It ensures that only the brightest parts of the image, mainly the glaze reflections, produce the glow. Everything else stays untouched. Set smooth to 0.15. This helps the glow fade naturally into the surrounding pixels instead of stopping abruptly. Set strength to 0.06. Keep this value small. If the strength becomes too high, the glow spreads too far, and we lose that tight, glossy highlight. Set saturation to 0.75. This keeps the warm tone of the glaze intact without pushing the colors too far. Set glare size to 6. This creates a soft, photographic bloom that works beautifully with glossy materials under strong directional light, exactly like our current donut scene. Finally, set quality to high. For final output, always use high quality. It prevents artifacts and keeps the glow smooth and clean. Now, take a look at the image. The effect should feel subtle, but meaningful. This one is before, and this is after. The highlights spread slightly, the glaze remains shiny and appealing, and the render starts to take on that final, polished look, almost like it was captured by a real camera in a controlled studio. Now, let's preview this effect live. Change the bottom window to a 3D viewport. Switch the viewport shading to rendered mode. Then open the small drop-down next to the shading icon. Under Compositor, choose Always. As soon as you enable that, the compositing effects appear live in the viewport. No more guessing, no back and forth test renders. You're now seeing the final composited image while you work. You can orbit around the scene, make small adjustments, and instantly see how the glow reacts. Watch how the highlights shift as the viewing angle changes. That behavior is very similar to how a real camera lens reacts when strong light hits glossy surfaces. Alright, that covers everything we need for compositing in this tutorial. Now we can finally start rendering. If you only needed a single image, you could go to Render, Render Image, or simply press F12. That would give you one fully rendered frame, which you could then save manually. But in our case, we're creating an animation. That means we need every frame, not just one. So instead of Render Image, we'll use Render Animation. When you render an animation, Blender calculates each frame one by one and automatically saves them to the output folder you defined in the output settings. You don't have to save anything manually. Blender takes care of that for you. Now, when you look at the file format options, it's tempting to think, I want a video, so I should choose a movie format. That sounds reasonable. But in practice, it's not the safest workflow. Rendering directly to a movie file can be risky. If Blender crashes, if the system shuts down, or if the render is interrupted halfway through, everything is lost. All that time, gone. And with longer renders, this happens more often than most people expect. That's why, for animation work, it's always safer to render an image sequence. Each frame is saved as its own individual image file. So if something goes wrong, you don't lose everything. You simply continue rendering from the last completed frame. It's safer, it's more flexible, and it gives you more control later in post-processing if you ever need it. For most projects, PNG works perfectly well. If you want slightly higher robustness, TIFF is also a great option. You'll also notice options for 8-bit and 16-bit color depth. 16-bit stores more color information and gives you more flexibility in color grading, but it also creates much larger files. For this project, 8-bit is more than enough. Once your output folder is set and your file format is selected, the render setup is ready. All that's left is to choose Render, Render Animation, and let Blender generate the sequence. But before committing to the full render, it's always a good habit to pause here for a moment and run a quick test. Rendering a single frame, or even a short range of frames at lower samples, can save you a lot of trouble later. It gives you a chance to catch issues early, before you spend hours, sometimes days, rendering the full sequence. This step becomes especially important for longer animations. Small problems often hide until the render is already underway, and a quick test render helps prevent that. So take a moment here and inspect the scene carefully. It's one of those steps that doesn't feel exciting, but it can save a huge amount of time later. One of the first things we should verify is face orientation. Switch your workspace to Layout. While you're in Solid View, open Viewport Overlays and enable Face Orientation. As soon as you activate this option, Blender shows the direction each face is pointing. Blue faces are correct, they face outward. Red faces indicate flipped normals, the face is pointing inward. At first, this might seem like a small detail, but it matters more than many beginners realize. Shaders, lighting, and even the camera all expect surfaces to face outward. When normals are flipped, light behaves incorrectly. Materials may look broken, and during rendering, strange artifacts can appear, often much later when they're harder to trace. So if you see red faces, never ignore them. Pay special attention to the inner cube in our scene. Remember, we created that cube while the camera was outside of it, which means the camera expects the cube's outer faces, not the inner ones. If you find flipped faces, switch to edit mode. Select everything by pressing A, then press Shift-N to recalculate normals. In most cases, that fixes the issue immediately. If it doesn't, which can happen with enclosed or layered geometry like our cube, open the Recalculate Normals options and enable Inside. This tells Blender to orient the normals inward, which often resolves issues for interior meshes. When you're finished, take one more careful look. Everything should now appear correct. Once that's confirmed, you can move forward with confidence, knowing the geometry is clean and the render won't produce avoidable shading issues later. Next, let's check for objects that should not appear in the final render. In this scene, we still have the individual sprinkle objects. These exist because the geometry node system uses them as references, but we don't want them to render individually. Here's the clean solution. Open the outliner, find the sprinkles collection, then disable the camera icon for that collection. This keeps the sprinkles visible in the viewport so you can continue working, but prevents them from appearing in the final render. And importantly, it doesn't break the geometry node system. Everything continues working exactly as expected. Now remember earlier we used a random value node for sprinkle scale and rotation inside geometry nodes. When rendering a single image, you won't notice any issue. But during animation, Blender recalculates the random value for every frame. That means the sprinkles would change rotation and scale continuously from frame to frame, which obviously isn't realistic. In the real world, sprinkles don't shift or rotate as the camera moves. They stay fixed in place. So to fix this, we need to apply the Geometry Nodes modifier. But before doing that, there's one more small issue to address. While preparing this section, I noticed that some sprinkles slightly intersect the icing mesh. A few even sink through the glaze and touch the donut surface. In a still render, this might look harmless, but in animation, overlapping geometry can cause shimmering or flickering, a very common artifact when two surfaces occupy the same space. Even if it's barely noticeable in a still image, once the camera moves, it becomes distracting. So first we'll fix that. We'll add a small offset to lift the sprinkles slightly above the glaze. Go to the Geometry Nodes workspace, press Shift-A and add Set Position. Place it between Distribute Points on Faces and Instance on Points. Now drag from the normal output of Distribute Points on Faces. Add a Vector Math Scale node. Then connect its vector output to the offset input of Set Position. You'll notice the sprinkles immediately start floating above the surface. That's because the default scale value is 1, which is far too large. So reduce the scale value to 0.005. This lifts each sprinkle slightly along the surface normal, just enough to prevent intersection. Next, go to the Rotate Instances node. Set the pivot values to 0. This ensures that each sprinkle rotates around its own center. Now return to the Layout workspace. Apply all modifiers for the chocolate glaze, just like we did earlier. Then either apply or remove the Geometry Nodes modifier for the sugar glaze. At this point, what we want is a final, clean, production-ready donut. And now, it's ready. The next thing to check is object intersection and positioning. Even very small overlaps can become noticeable once the camera starts moving. In a still viewport, tiny intersections can easily go unnoticed, but in animation, especially when reflections and shadows interact across glossy surfaces, those overlaps become distracting. So if the donuts are touching or intersecting, adjust them slightly. Now I might rotate the chocolate donut slightly along the x-axis. Right now it's tilted a bit to one side. If I orbit around the scene, you can see the donut slightly intersecting the plate's edge, so I'll rotate it along the y-axis, very gently. Alright, let me go back to camera view. I may move it slightly toward the center, like that. Maybe adjust this one too. Let's check again. It's still intersecting the plate, so I'll rotate it just a bit more, carefully, and maybe lift it slightly upward, just enough so it rests naturally without cutting into the plate. Yeah, that looks much better. In your scene, if the plate and coffee mug are sitting too close together, just give them a little more space. Each object should maintain a small gap while still feeling like part of the same composition. Take a moment to adjust things until the camera captures a clean hero view of the scene. Now, let's carefully examine lighting and exposure. This is one of those quiet steps that can completely change how realistic a render feels. Go to Color Management and temporarily change the view transform from filmic to false color. False color isn't meant for beauty. It's a diagnostic tool. It reveals something that is often difficult to judge just by looking at a render, how exposure is distributed across the image. Most of the time, evaluating lighting directly from the rendered view is surprisingly difficult. Even when a scene looks good, it's not always obvious whether the lighting is actually balanced. And this becomes even harder when you're still developing your lighting intuition. You place a few lights, maybe a directional light, an area light, sometimes an environment light. Then you render the scene, and you think, looks good. But looking good isn't the same as being balanced, and it isn't the same as being technically correct. Until you build lighting sensitivity over time, it's very hard to evaluate light purely by eye, especially from a rendered image, because the eye adapts. Your brain quietly compensates for brightness and contrast. So if you're new to lighting, if you don't yet have a strong understanding of light behavior, or you're not deeply familiar with color science, how do you analyze your lighting technically, not just visually? That's the real question. And the practical answer is very simple. We use false color. False color converts exposure values into colors. It removes the beauty of the image and shows the raw exposure distribution instead. Now you'll see different colors across the image. Each color represents a different exposure range. Yellow indicates mid to high exposure. This is generally a healthy range for well-lit surfaces. Red or orange indicates very bright areas. These regions are approaching clipping. Green or cyan represents midtones or properly exposed shadow regions. Blue indicates darker shadow areas. Now, before adjusting anything, just observe. Don't change the exposure yet. Right now, I'm simply demonstrating how to read the image. Pay close attention to white areas. White is critical. White means clipped highlights. It means there is no data left there, no texture, no surface detail. That part of the image will render as flat white. And most of the time, we want to avoid that. Now look at red areas. Red indicates strong brightness. It's not clipped yet, but it's getting very close. A few small red areas are acceptable, especially on strong specular highlights. But red should never dominate the scene. If you start seeing white regions or red spreading across entire surfaces, then you slightly reduce light intensity or lower the exposure. Just enough for the white areas to disappear and for the red regions to become controlled. Once you learn to read false color, you stop guessing. You stop relying entirely on your eyes. Instead, you start making lighting decisions with confidence. And that's how your lighting skills improve much faster. Not by adding more lights, but by understanding what your light is actually doing. Now, pay attention to how exposure is distributed. This scene actually contains 3 very different material behaviors, and each one responds to light in a completely different way. That's where lighting becomes more challenging. First, the marble plane. In real life, marble is bright, crystalline, and reflective. This surface doesn't just receive light, it reflects a large portion of it back, which means it's extremely sensitive to brightness. If the light becomes slightly too strong, the surface begins to clip. Details disappear. The texture fades into brightness. So a strong directional light isn't always ideal for marble. To preserve detail, we usually rely on soft area lighting. Second, the sugar glaze. This material is translucent and glossy. Light enters the surface, travels through it, scatters slightly, and then exits again. To support that behavior, the glaze benefits from 2 qualities of light. First, a physical directional light, strong enough to pass through the glaze and create depth. Our cycle sunlight handles that transmission. But we also benefit from a softer secondary light. That second light helps maintain the smooth highlight across the outer surface. Third, the chocolate glaze. Chocolate behaves very differently. It's darker, thicker, and largely opaque. When light hits chocolate, much of the energy is absorbed instead of reflected. So instead of sharp reflections, we see soft diffusion. The lighting setup that works for marble will also work well for objects like the coffee mug and plate. They behave similarly under light, so we don't need to treat them separately. But now, all 3 materials exist in the same scene. And that's where the challenge appears. The light setup that works for marble doesn't necessarily work for sugar glaze. The lighting that preserves chocolate may not work well for marble. Each material responds differently, so the question becomes, can one global light setup solve everything? The answer is no, because global lighting treats every surface the same. But these materials do not respond the same way, so we need another approach. Instead of relying only on global lighting, we sometimes adjust how specific lights influence specific objects. In other words, we control how light interacts with different materials. At first, that idea might sound strange. How can one scene contain different lighting behavior for different objects? But it's absolutely possible, and in a moment, I will show you exactly how it works. Before we do that, let's observe a few problems that are already happening in our scene. First, look again at the marble plane. It's becoming too bright across large areas. Meanwhile, the objects sitting on top of it are not equally bright. This isn't because the light is necessarily too strong. It's because marble itself is very sensitive to light. Your first instinct might be to lower the exposure. Technically, that would reduce the brightness, but the moment you reduce exposure, everything else in the scene also becomes darker. Why? Because the lighting we're using right now is global. Any adjustment affects the entire image equally, and that's the limitation we're dealing with. Second, look at this deeper shadow area here. Imagine if the chocolate donut were replaced with a lighter object, something like ceramic. That shadow would feel perfectly normal. But chocolate is already dark brown, so when a shadow falls on it, the surface becomes too dark. Look closely. It almost turns completely black. And when a surface falls into that range, the chocolate loses detail. So this is another problem we need to correct. Third, look at the rim edge of the sugar glaze. Instead of staying reflective and translucent, the rim begins to look a little harsh. You can see a strong edge shadow forming there. Why does this happen? Because the chocolate glaze absorbs most of the incoming light. Very little of that light is reflected back toward the sugar glaze. In the real world, objects illuminate each other through indirect reflection. That surrounding light is what helps glaze maintain its transparency from different viewing angles. But in this scene, the chocolate is absorbing most of the light energy. Almost nothing is bouncing back. So the sugar glaze loses that environmental reflection, and the rim starts to look harsher than it should. So now we have three clear issues. The marble is too bright, the chocolate shadow becomes too dark, and the sugar glaze rim loses its natural reflection. And somehow, we need to correct all three. Most of the time, artists rely on global lighting, light that affects every object equally. That approach works beautifully when materials behave similarly under light. If everything reflects and absorbs light in a comparable way, global lighting works perfectly. But when objects respond very differently, like in our scene, we introduce local lighting. Lighting that affects only the objects we choose. So we keep the global light and carefully mix it with local light. That balance is what gives us professional lighting control. First, let's create a new collection for the objects we want to treat separately. Select the sugar glaze. Then, select the chocolate glaze. Press M. Create a new collection. Name it something like Sun Affected. Now select the sunlight. Go to Object Properties, the orange square icon. Expand the shading section and find Light Linking. Here we can link the sunlight only to the objects we want it to affect. Click the drop-down next to the collection icon and choose the collection we just created. You can enable or disable objects individually. Since we want strong highlights on the glaze, keep both glaze objects enabled. Then click Make Single User. Good. Now, let's observe the result. Only the glaze objects are influenced by the sunlight. Their lighting remains consistent. But the countertop, the coffee mug, and the plate, they are no longer affected by that direct sunlight. In a normal rendered view, the difference may be subtle, but if you switch back to false color, the difference becomes very clear. We've prevented the sunlight from over-brightening the countertop, the plate, and the coffee mug. That was the goal. Whatever brightness remains now comes from the general scene lighting. Later, we'll slightly reduce the sunlight strength. Now let's move back to the glaze lighting. Before adding anything new, I want to clarify something. We're about to introduce a fourth light, and I don't want this to be misunderstood. In most scenes, 3 lights are more than enough. For the majority of 3D work, that's the ideal setup. However, when a scene becomes slightly more complex, we may introduce a fourth light to solve a specific problem. But in general, you should avoid going beyond 4. Whenever possible, try to solve lighting problems using 3 lights or fewer. Instead of adding new lights immediately, focus on improving how the existing lights work together. Because once too many lights enter the scene, surfaces start to flatten. Materials lose depth, shadows lose meaning. Instead of realistic surfaces, you end up with something artificial. Lighting determines how every object appears. If lighting is incorrect, shape and material both suffer. Details disappear. So treat lighting carefully. Now, for the dark shadow on the chocolate glaze and the harsh rim shadow on the sugar glaze, we'll introduce one small area light. Both issues come from the same cause: directional light without supporting bounce light. Sugar glaze is extremely sensitive to directional light, especially along the edges opposite the main light source, where the sunlight doesn't directly reach, and where there's no surrounding reflection. The glaze falls into shadow too quickly. So what do we need? A soft fill light placed opposite the sunlight. First, move the 3D cursor to the side. Press Shift-A, Light, Area Light. Now rotate it along the Y-axis. Press R, then Y, and rotate to -90 degrees. Scale the light up. Roughly match the size of the plate. Then move it upward. Bring it closer to the donut. Rotate it again slightly along the y-axis so the light points downward toward the donut. Yes, like that. Now move it along the x-axis, placing it quite close to the donut. It can even move slightly toward the center. The light should remain close enough that the chocolate surface absorbs most of the light. Now let's adjust the light settings. Open the light properties. Set power to 100. Set exposure to 1.5. Enable temperature. Set it to 3000. We don't want a neutral white light here. It should harmonize with the sunlight. Slightly warm. By the way, if these values work for you, that's great. If not, try adjusting them slightly and observe the result. That's one of the best ways to learn lighting, not by copying numbers, but by changing them and watching what happens. While preparing this tutorial, I experimented with these values quite a bit. That's part of the process. You might wonder why I'm not experimenting live on screen. The reason is simple. This tutorial follows a structured workflow. If we tested every value during recording, the lesson would become unnecessarily long. So I focus on explaining the technical structure, and I encourage you to explore the adjustments yourself. That's how real confidence develops. Now we need this area light to affect only the glaze, just like we did with the sunlight. Go to Object, Properties. Under Light Linking, choose the same sun-affected collection, then click Make Single User. Now I render the image again. You should notice a clear improvement. The heavy shadow that was sitting on the chocolate glaze is now lifted, and that harsh rim shadow on the sugar glaze has disappeared. Now everything behaves much more naturally. The objects still feel connected under the global lighting, but individually, each one receives the light support it needs. That balance is exactly what we're aiming for. Now, as you can see, the countertop is still slightly bright. Technically, we could solve that by lowering the sun strength, but instead, we'll adjust the scene composition. Because in 3D rendering, composition matters just as much as lighting and materials. Object placement shapes the visual story. Even though our scene represents a morning kitchen, we're not building the entire kitchen. We only need the small area where the donut is placed. So first, look at the empty space around the scene. Do we really need that much distance? Not really. Second, the countertop currently behaves as if it's sitting outdoors under strong midday sunlight, as if there were no ceiling, no walls, and unlimited light entering the room. We don't need that much light. Select the countertop. Then, Shift-select the backsplash and the cube. Press G, then Y, and move them closer to the donut. Like this, just a little closer. Now I notice something else. The backsplash and countertop are not snapping perfectly together. In your scene, they might be aligned already, but it's worth checking. This corner looks small now, but once it gets closer to the camera, it becomes noticeable. A small adjustment here prevents unnecessary distractions and keeps the viewer's focus on the donut. So I press G, then B, switch to vertex snapping, and snap the edges together precisely. Then I select the cube, press G, then B again, and snap it into position. Nice. Now nothing pulls attention away from the subject. Next, let's shape that early morning sunlight. A soft golden ray coming from the side, falling across the donut. Light doesn't depend only on strength, it also depends on how it enters the space. If the window opening is large, sunlight spreads as it enters. The light becomes softer and less directional. But if the opening is smaller, the rays enter more tightly, and that's when you get those beautiful, dense morning sun rays. Select the cube, enter Edit Mode, select this side edge, and move it along the Y-axis. Then, select the top edge and move it down slightly. That's enough. Now select this edge here and move it again along the y-axis. Maybe just a little more. What we're aiming for is a condensed light ray. For that effect, we need a smaller window opening. Let's check it from the camera view. I will move this edge slightly upward. Now we're controlling the sunlight, so it mainly falls across the glaze. Its purpose is to support glaze transmission and enhance the subsurface scattering inside the donut. We don't want it hitting the marble directly. The marble will show its texture better under the area light. This is much better. But now the room feels too dark. We tightened the sunlight so much that it only touches the donut, which was intentional. But in a real morning kitchen, the room would never become this dark. Even without electric lights, ambient light would still enter from outside. And this is exactly where our main area light becomes important. Select the large area light. Go to the light settings. Increase the power to 200. Then reduce the temperature to around 4,200. Just enough to preserve that morning mood. Beautiful. Now the marble receives soft, delicate light that preserves its texture instead of washing it out. This area light now behaves like the room's ambient lamp. So now you can clearly see. Every light we added had a specific purpose. The Cycles physical sunlight for glaze transmission and donut subsurface scattering. The secondary sunlight for strong specular highlights on the glaze. The small area light to soften harsh shadows and recover chocolate detail. And the large area light to illuminate the room and reveal the marble texture. And remember, anything outside the camera frame doesn't matter. In 3D, everything is an illusion. We only make what the camera sees feel real. What exists outside the frame is irrelevant. No one will ever see it. And that illusion depends heavily on composition. Finally, go to World Properties. Reduce the sun elevation to 13 degrees. This creates a long, soft shadow across the scene. Then reduce the sun strength to about 0.3. Because we're now using 4 lights. If we kept it at 0.5, it would overpower the scene. That value works when sunlight is the only light source, but in this setup, it would break the balance. Now look at the result. The marble holds its texture and behaves like real kitchen marble. The sugar glaze remains glossy and slightly translucent, more natural, more appealing. The kind of glaze you'd expect on a premium donut under morning light. The chocolate glaze feels richer and creamier, and the donut itself looks freshly baked. That was the goal from the beginning of this tutorial, and now we've reached it. 2 donuts, sugar glaze and chocolate glaze, sitting beside a cup of hot coffee in a quiet morning kitchen. That's the story we built, and now the scene supports that story. This is our final exposure distribution. Everything is balanced. Nothing is overexposed. Nothing disappears into darkness. Earlier, we had 3 main lighting problems across 3 different materials, and we solved all of them by carefully combining global light and local light while adjusting the composition of the scene. So remember this, lighting isn't about making a scene bright, and it's definitely not about adding lights randomly. Without strong lighting, even strong materials will never look correct. You saw that clearly in this scene. The object stayed the same, the materials stayed the same, but once the lighting changed, the difference became huge. Lighting skill is essential. In real production, artists often spend far more time on lighting and materials than on modeling. Many models are imported, free or paid. You model only when necessary, but you constantly refine shaders, lighting, animation, compositing, and rendering. That's the real workflow of a 3D artist. Throughout this tutorial, I tried to keep everything clear and reproducible. We started with simple steps and gradually refined the scene piece by piece. That's why I kept the deeper lighting discussion until the end. The donut itself is simple, but the goal was never just the donut. After this tutorial, you'll build many different scenes with different materials and environments. So the real goal here was to introduce a production-style workflow. I structured this tutorial very similar to a full course. If this helped you learn something meaningful, consider subscribing to the channel and share it with others who want to learn 3D freely and properly. Alright, one final check. Select the camera, then open Camera Data Properties. For a donut showcase like this, a focal length between 50 and 80 millimeters usually produces a clean product-style perspective. I believe we already touched on this earlier in the animation section, but let's quickly confirm it here. Set the focal length to around 65 millimeters. This gives us a perspective, close to how our eyes normally see food in real life. While we're here, you'll also see the option to enable depth of field. Depth of field allows the main subject to stay sharp, while surrounding elements gradually blur depending on the focus distance and the f-stop value you set here. This technique works especially well when you don't want every object in the scene to have the same level of sharpness. Background elements, like the backsplash in our scene, should remain slightly softer. We don't want them competing with the donut for attention. The donut is the hero object. When depth of field is first enabled, the image may appear blurry. That's normal. The camera simply doesn't know where to focus yet. Use the eyedropper tool, then click the object that should remain sharp, in our case, the sugar glaze. Now Blender knows exactly where the focus point should be. If the blur becomes too strong, slightly increase the f-stop value. This tightens the depth of field and restores clarity where needed. The result begins to feel much more cinematic, similar to how a real camera behaves. However, for this tutorial, I'll leave depth of field disabled, because we're rendering an animation, and during the animation the camera moves closer to the donut. If depth of field were active, the donut or the coffee mug could unintentionally drift out of focus, which isn't what we want here. Depth of field works best for still renders, where the camera remains fixed and the focus can be tuned very precisely. Alright, at this stage, everything is ready. Now go to Render and choose Render Animation. Blender will begin processing the animation frame by frame, saving each frame automatically to your output folder. Depending on your hardware, this could take several hours, sometimes even overnight. Throughout this tutorial, my goal was to maintain a good balance between quality and performance, and at this point, that balance is working well. If this is your first time rendering a full animation, the waiting can feel a little long. That's completely normal. Just let Blender do its work. Leave your system running, step away for a bit, grab a coffee, or work on something else while the frames render. One quick recommendation. Before the full render finishes, open the first few frames that Blender produces. Take a moment to confirm that everything looks consistent. Lighting, glaze highlights, exposure, compositing. Make sure everything behaves exactly as expected. Once the render completes, you should see roughly 120 TIFF images inside your output folder. And with that, the render stage is finished. Now we'll turn this image sequence into a final video using Blender's video editor. Go to File, New, and choose Video Editing. To import the rendered frames, press Shift-A, then select Image Sequence. Navigate to the folder where your rendered images are stored. Select all frames. You can simply press A to select everything, then add them as a strip. Now press spacebar to play the timeline. You'll see the animation start to play. By default, Blender plays back at 24 frames per second, which is a standard cinematic frame rate. But if you prefer slightly smoother motion, you can change the frame rate to 30 frames per second. With that adjustment, the animation feels a bit smoother. Now notice something. The animation plays until frame 120, and then the screen turns black. We don't want that. Instead, we want the final hero frame to remain visible for a moment before the animation loops again. To do that, we simply extend the last frame. Select the final frame strip, then drag it toward the end of the timeline. Now play the sequence again. Better, but the hold feels a little long, so let's adjust the timeline. Set the end frame to 200. Play it one more time. Yes, now the timing feels much more balanced. Alright, now let's export the final video. First, choose your output folder in the output settings, just like we did earlier. Blender will automatically select FFmpeg video, which is flexible and reliable, so we'll keep that. Under encoding, choose MPEG-4 as the container. For output quality, select high quality or perceptually lossless. That will give us a clean, sharp video, perfect for this animation. If you want to include audio, you can add it here. But for most food animations, silence actually works very well. The visuals carry the entire presentation. Now click Render Animation again. This time, Blender will not render new frames. Instead, it will take the frames you already rendered and combine them into a single video file. When the process finishes, you'll have a clean, polished animation ready to share. And one important habit to remember: always keep your original image sequence as a backup. Later, if you ever need a different video format, a different compression setting, or a different export resolution, you won't need to render the entire animation again. You can simply export a new video from the existing frames. And that's it. Nice work. You've just completed a fully realistic glazed donut animation from scratch. From modeling, to materials and shader behavior, to lighting, to animation, to rendering, to final video export. You've walked through the entire production workflow, and now the project is complete. If this tutorial helped you learn something new, feel free to leave a comment and share your results. And if you found it valuable, consider subscribing. It really helps the tutorial reach more people who want to learn Blender the right way, and for free. Thank you for following along. I will see you in a future video.